Hey guys, I'm sure you guys are doing well and I'm sure you guys are studying hard. So welcome to my AS paper walkthrough for the Edexcel May 2024 paper 8 MAO/01. So yeah, good paper, 2 hours long. There were 14 questions in here. Couple of really good questions, couple of sneaky ones, but I'm sure you guys will find it okay. As always, the timestamps will be in the description, so you can just quickly go to whatever questions you'd like. And yeah, that's pretty much it. I've done loads of these walkthroughs now, so I feel like I know what I'm saying in each of these intros. But yeah, that's pretty much it. Let's get into it. Okay, so question one says find the integral of 2 root x minus 3 over x squared. Given your answer in simplest form for 4 marks. Okay, so it's question one, it's an integration problem and it's an AS paper. So obviously it's going to be the power rule. However, the way it's given to you at the moment, we can't really do much of it. You need to manipulate it first. So get everything in terms of powers and separate. So I'm going to start off by rewriting that root x. 2 root x is the same as 2x to the power of a half, isn't it? And then minus 3 all over x squared. And now, because we know we're going to have to use the power rule, we want it to be term by term. We want to separate the terms. So I'm going to separate the fractions. That becomes 2x to the half over x squared minus 3 over x squared dx. So remember, I'm just using algebra here. I'm not doing any integration so far. Now, to finally get it in the right form, that 2 is a constant. I can put at the front. X to the half minus x to the half over x squared. We take away the powers. 1/2 take away 2 is 1/2 minus 4/2, which is minus 3 over 2. So that becomes x to the power of minus 3 over 2. And then that there, 3 over x squared, because it's on the bottom, it's going to be a minus, isn't it? So it's going to be 3x to the minus 2 dx. Now we are in a position to start integrating, right? Because we've got it in the form of x to the power of n. So now what do? We add 1 to the power divided by the new power. So that's going to be 2. And then if I add 1 to that, minus 3 over 2 plus 1, which is 2 over 2, that's going to be minus a half. So x to the minus a half divided by the new power. And then we've got a minus 3x, and then add 1 to the power is going to be minus 1 divided by the new power minus 1 plus your constant of integration. And now it's just a matter of just tidying that up, isn't it? So doing that there, we're dividing by a half. That's the same as times by 2. We've already got a 2 at the front. It's going to be a 4. There is a minus there, so it's going to be minus 4x to the power of minus a half. And then minus 3 over minus 1 is a positive 3. So positive 3x to the minus 1 plus your constant of integration. And that is your answer for question one. 4 marks in the bag. Okay, so question two says f of x is equal to 2x cubed minus 3ax squared plus bx plus 8a, where a and b are constants. Given that x minus 4 is a factor of f of x, part A says use the factor theorem to show that 10a is equal to 32 plus b for 2 marks. So I've just got the question summarized here just so we don't need to keep going up and down, part A anyway. So we need to use the factor theorem. Remember, from the factor theorem, if x, let me write here, if x minus a is a factor, right, of f of x, then f of a is equal to 0. Yeah. So all we need to do is essentially plug in 4 into f, equate it to 0, and we should be able to rearrange to get that equation that they want. So we're gonna plug in 4. So part A, I'll do it here. So f of 4. If I plug in 4 into there, it's going to be 2 lots of 4 cubed, minus 3a times 4 squared, plus b times 4, plus 8a, and this should equal 0. So now it's just a matter of just rearranging. So 4 cubed is 64, double that, that's 128. I've got a minus there, 3 times 4 squared. 4 squared is 16, 16 threes are 48, so that's going to be 48, and then an a. And then we've got 4b, and then we've got plus 8a, and then this is equal to 0. Now, whenever you're doing a show, that always have what you're trying to show at hand and then just compare with where you are at currently. So this is where we are at. We need 10a is equal to 32 plus b. So I need an a on the left and the constant and the b term on the right. So what I'm going to do is simplify these. So minus 48 plus an 8, that's be minus 40. I'll times by minus 1 after. So minus 40 a is going to equal, and then that minus 4b is going to go there because I'm going to move that there, aren't I? And then that is going to be minus 128. like that. So this is where we are at. Now, we need a positive 10. These all are divisible by 4. So I'm going to divide by a negative 4, aren't I? If I divide by negative 4, that becomes a positive 10. So that'd be 10a. That would be a positive b, like that. And then that would be 6432. Perfect. And obviously they want the 32 first. So just write like this, 32 plus b. And that is part A. That is part A finished. So let's go on to part B, which I've got summarized here. So, given also that x minus 2 is a factor of f of x, part B says express f of x in the form f of x is equal to 2x plus k minus times x minus 4 times x minus 2, where k is a constant to be found. So, for me, f of x is given as 3 distinct factors. So that tells me I need to factorize it completely, right? Once I factorize it completely, I'd be able to figure out what k is, isn't it? So the main thing is I'm going to use this bit of information to figure out what f actually is, because remember f currently is in terms of a and b. So what we're going to do is we're going to use this second piece of information to get another equation in terms of a and b to solve simultaneously. So let's get the function again. The function was that one there, that. And then we already have an equation in part A. So with these types of questions, you see you have an equation in terms of A and B that we need to just show. It's always going to be simultaneous equations you're going to use for these types of questions. So from that one, if I use that, x minus 2 is a factor, that will tell me that f of 2 will equal 0. So let's plug that in. So it's going to be 2 lots of 2 cubed minus 3a, and then 2 squared plus b lots of 2 plus 8a is going to equal 0 this time. So doing that, I'll do it here. That's going to be 2 cubed is 8, 16. 16. 4, 3, 12. So that's going to be minus 12a plus 2b plus 8a is equal to 0. So tidying that up, what do we have? We've got a minus 12 plus an 8. That's going to be minus 4. So that's going to be minus 4a like that. And then we've got plus 2b plus 16, isn't it, is equal to 0. So let's solve this simultaneously. Let's move the 16 over. So it's gonna be well, you know what? Should I put it? You know, I'm gonna move the A over just so it looks nicer. So it's gonna be 4a is gonna equal 16 plus 2b. I'm just using it. I'm gonna write it like that. So all I've done is just move that there, and then obviously swapped the 2b and the 16, so it's not a problem. The reason why is just due to the fact that the show that in part A has that same structure. 10a is equal to 32 plus b. I wonder why. So 10a, so this is equation 1. 10a is equal to 32 plus b is our equation 2. We want to solve simultaneously. So I think you can just put this in the calculator from here, but I'll just do it. What I'm going to do, I'm going to half that one, aren't I? I'm going to divide that equation by 2. That's going to give me a 2a is equal to 8 plus b. And then I can put that one again underneath. So 10a is equal to 32 plus b. And now we can take the b's away and then solve. So taking that away, you know what I'll do? Just because I don't want it negatives, I'm going to do 2 like that there. So let me do 2 and then 1. And then what I'm going to do, I'm going to do 2, take away 1 like that. So I'm going to do bottom, take away top. So if I do that, that's going to be, I'm going to write it just so it's super clear, It's a video, so let me just be super clear. 8 plus b, like that. So that's going to be an 8a. That's going to equal 32 take away 8 is 24. The b's cancel. So that means that a is equal to 24 over 8 is 3, isn't it? So a is equal to 3. That's fine. Now that we've got a, we can plug it in to figure out what b is. I'll plug it into there. I'll plug it into this one. So it's going to be 2 lots of 3 is equal to 8 plus b. That means that 6 is equal to 8 plus b. So therefore b is going to equal 6 take away 8, isn't it? Which is going to be minus 2. So b is equal to minus 2. So a is equal to 3, b is equal to minus 2. Now that we have that, right? Remember what we're trying to do. We're trying to express the function, the cubic, the polynomial in factorized form. So we need to figure out what k is, don't we? So what I'm going to do now is, now that I've got A and B, I'm going to write out f of x in its entirety. So f of x is going to equal 2x cubed. You know what? Let me just copy this so I don't need to keep going up and down, to be honest. That's the best bet. So let me just grab this here and put this right here. Perfect. Okay. Okay. So where are we? Where are we? Okay, we are here. So it's going to be 2x cubed minus 3a, three threes are 9, so minus 9a x, sorry, not 9a, 9, and then x squared, and then plus b, which is minus 2, so minus 2x plus 8a. 8 times 3 is 24. So this is what f of x is. Now we've got our function f completed, right? We need to factorize it. How do we do that? Well, there's a couple of things you can do. I think the most conventional thing you can do here is get one of your linear factors, either x minus 2 or x minus 4, and perform long division. That way you get the quadratic and then you just factor that out, and then one of them will be one of the other factors you've seen, and then you'll get the 2x plus k factor like that. Or you could you could compare coefficients, and I think that's more efficient in this case. So that's what I'm going to do with this one. So let me grab this here. So what am I going to do? I'm going to write f of x on the left hand. You know what? I'm going to do it on the next page just so I don't run out of room, actually. And this is the next part, C. I'll do that later. I'll put it here. Put C here. Okay. So what I'm going to do is I'm going to grab this. I'm going to grab 2x, this function here. And then I'm going to paste it there. And put that there. Okay. And then we know that this is going to equal, from the question, 2x plus k, and then x minus, I mean, I'll put it in the same order, x minus 4, x minus 2, okay? So x minus 4 and then x minus 2. Now, what I'm saying is, because I'm trying to figure out what k is, I've got the expanded version of this function on the left-hand side. If I was to expand all of this, right, you're going to get an x cubed term, you're going to get an x squared term, you're going to get an x term, you're going to get a constant term. Because these are the exact same thing, the coefficients of each of those terms that we're going to get on the right-hand side must match the coefficients on the left-hand side, comparing coefficients. So what I want to do to figure out what k is, well, instead of expanding everything, which I could do, I could say, well, the constant term on the right-hand side is 24. When I expand, sorry, on the left-hand side is 24. When I expand the right-hand side, the constant term will be the same, isn't it? So what I'm going to do is say, well, how would I get that constant term? You're just going to multiply all of the constants here, aren't you? So that constant there, and that constant there, right? So if I times all of those together, let me just times the plus k as well. Highlight the plus as well. So it's going to be that and that times together. That's going to be k times minus 4 times by minus 2. That is going to equal a positive 8k. Now, this is the constant term on the right-hand side. Because I know it's equal to the left, it must mean that the 24 must equal that 8k. Like that, right? So I'm going to just say that 8k is equal to 24. So therefore, 20k is going to equal 24 over 8. So that means that k is equal to 3. So therefore, k is equal to 3. And therefore, your final answer for f of x in factored form is going to be 2x plus 3, and then x minus 4, and then x minus 2. Whoops. And that is it, right? So that is, I think, is the best way to do it. Again, as I said before, you could have essentially, which I'm sure some of you probably would have done, you probably would have used long division. So let's say you want to use x minus 4 as the factor, like that, and then you're going to plug that in there. On the bottom, minus 9x squared minus 28 minus 2x plus 24. And then use long division to figure out what the quadratic is. Factorize that, and then you'll get your 2x plus 3 factor. Hopefully that makes sense. So yeah, that is part B done. We're going to go into part C now. So part C, it says, hence, state the number of real roots of the equation f of x equals 0. Now, I've got f of x, the expanded version, and the factorized version here, right? Just because that's what we need. So we want the number of roots. Well, we're going to use what we did in part B, which was to show that the function could be written as that, which is factorized. There are 3 linear factors. You're going to get a root at every 0 of these factors here, right? So there's going to be 3 roots. So the answer for part I is just 3. There are 3 roots. 1 at 2x plus 3 is equal to 0, which is minus 3 over 2. 1 at x is minus 4, 0, which is a 4, and 1 at x is equal to 2. Let me write this here. So x equals 2 is one root, x equals 2, x equals 4, and x is equal to negative 3 over 2. When you solve that, make it equal to 0. So there are three roots. Part double line says write down the largest root of the equation f of a third x is equal to 0 for another mark. Now, you have function here, f of x, and then they've asked you about f of a third x. What topic comes to mind? This is just graph transformations, guys. You need to know these very, very well because depending on what type of transformation you have or what type of expression you have here determines the type of transformation. So what does this mean? Now, when you've got something on the inside, this just affects the x coordinate. Now, the number you multiply the x by, which in this case is a third, right? You divide every x coordinate by that number. So in this case, what will happen is that every single x coordinate will be divided by a third, which in other words is the same as multiplying by 3. So essentially, each of the roots are going to triple in size, aren't they? So what I'm going to do, just to make it super, super clear, is I'm going to say f of x, right? What are our roots? Our roots for f of x are going to be minus a third. Sorry, not minus a third. Minus 3 over 2, positive 4, and positive 2. Now, under that graph transformation, f of a third x, every x coordinate gets divided by a third, doesn't it? So which means, let me write roots here. We're going to divide by a third, right? Which is the same as timesing by 3. So I'm going to just replace that with a timesing of 3. So each of these roots is going to be tripled, as I said before, which means that our new roots are going to be minus 9 over 2, which is minus 4.5. That's going to be a 12. That's going to be a 6. It says find the largest root or write down the largest root. Which one is the biggest out of each of these? It's 12. So therefore, the largest root is 12. And that is it. That is question 2 finished. Okay, so question 3 says, relative to a fixed origin O, point P has position vector 9i minus 8j. Point Q has position vector 3i minus 5j. Part A says find P to Q for 2 marks. So that's very, very straightforward. So part A, I'll do here. P to Q is just literally Q minus P, isn't it? So what I'm going to do is I'm going to write these as columns. And then once I finish, I'll write it in terms of I and J because it's in I and J. I need it in that form at the end. But I'm going to just use it in columns because it's just easier. So Q in column form is going to be 3 here, a minus 5 there, minus P, which is going to be a 9 and a minus 8. So remember, P to Q is just Q minus P. Yeah, OQ minus OP. So what is that going to be? 3 take away 9 is negative 6. And minus 5 minus 8. That's minus 5 plus 8. That's just 3. So therefore, in I and J form, it's going to be minus 6i plus 3j. So that is part A, minus 6i plus 3j. Part B says, given that R is the point such that QR is 9i plus 18j, part B says, show that angle PQR is 90 degrees. Okay. So, if PQR is 90 degrees, you could always visualize these as well, you know. That's why I like to do these types of questions. So angle PQR. So let's just say, for example, it looks maybe like that. Let's just say it looks like that. You know, let me draw some nice lines actually. Let's just say I've got a line like that, and then let's say I've got another line like that. Let's say this is P, that's Q, and that's R. If this is a 90-degree angle, as they've said, well, what does that imply about these lines here? Well, they would have to be perpendicular, and the gradients would have to be the negative reciprocals of one another, isn't it? So what you want to do is essentially work out the gradients of this line PQ, work out the gradient of QR, and then show that they are perpendicular because there'll be the negative reciprocal, or you can times them together and you get minus 1. So what we're going to do is we're going to work out the gradient of PQ. Now we know the vector PQ because we did it in part A. It's minus 6i plus 3j. So what does that actually mean? It means that I'm going to go 6 units to the left. Whoops. I'm going to go 6 units to the left, that minus 6. And then I'm going to go 3 units up, like that. So therefore, the gradient is just a rise over run, isn't it? 3 over minus 6. Let me put this there, though. So the gradient for this one here, this is PQ. Whoops. That is not great. 1 second, guys. like that. That's better. So the gradient of PQ, I put M, is going to be the rise, which is 3, over the run, which is -6, which is equal to -1/2 if I simplify that. So that means that this gradient here is going to be -1/2. And then QR we're going to do. So gradient of QR. So that is horrible, isn't it? My bad. Right. Grad of QR. That's going to be, what is it? 918, 9i plus 18j. So we're going to go 9 units. Let's just say 9 units is that to the right, and then we're going to go 18 units up like that. So again, the gradient, let me do it like that. The gradient for this one's going to be rise over run 18 over 9, which is 2. So that means that this gradient here is 2. So therefore, we've got -1/2 and 2. So they are the negative reciprocals of one another. But just to really bring home, you can just say that -1/2 times by 2 is equal to -1. So therefore, you can say, therefore, lines PQ and QR are perpendicular. Are perpendicular. So therefore, what was the angle? Wasn't it? Angle PQR is 90. And that's pretty much it for part B. Okay, let's go on to part C now. Okay, so part C says, given also that S is the point such that the vector P to S is equal to 3 times the vector Q to R, find the exact area of PQRS for 4 marks. Now, I've just got parts A and B summarized as well, just to have everything we need for the question. So we need to find the area of this quadrilateral PQRS, right? So what you want to do with these types of questions is always visualize it, look at it, right? So you can see what's going on. So what I'm going to do is I'm just going to get the diagram that I used to prove that angle PQR was 90 degrees. Now, let's complete this diagram. Right now, we know it's a quadrilateral. They've told us that S is a point such that P to S is a line. It's 3 times Q to R. So for me, that tells me that vector PS and vector QR are parallel. They must be parallel, aren't they? Because one is expressed as a multiple of the other. So for me, what that means is that if I was to start from P, then I would just draw a line so that it would look like it's triple Q to R, right? But what I'm gonna do, just because it's a sketch, I'm not gonna draw all of that, am I? So I'm gonna maybe put this maybe like that, to be fair, and then I'll put this like there. So that looks to be about triple, isn't it? I think that's all right. It's a sketch anyway, it doesn't really matter. So I'm gonna put this a bit lower. Now, let's join this. Has to be S, and then obviously that's Q to R. So R is going to be there now, actually. And I'm going to get rid of the gradients because I don't think I need it now. And I'm going to just join that line together right now. I'm going to join R and S together. So just like that. So we've got a quadrilateral, and one pair of sides are parallel. This is a trapezium. So they'll ask us to calculate the area of a trapezium. So what's the formula for the area of a trapezium? Well, that's just a half and then A plus B times by H, isn't it? So I'm going to say this is going to be our H, obviously the perpendicular height. I'm going to call this A, I'm going to call this B. So we need to figure out what A, H, and B are, plug it into this formula, and then we're done. Now, these letters A, H, and B, these are the distances, aren't they? So what do we know? We know the vector P to Q. That's what we did in part A. And I believe that the vector P to Q was -6i plus 3j. Yes, it was. So to find the distance, I need the magnitude of that, don't I? So -6i plus 3j, the magnitude is going to be equal to, just Pythagoras of that, -6 all squared plus 3 squared, which is going to be 36 plus 9, which is the square root of 45, which is 9 times 5, 3 root 5, isn't it? So that's 3 root 5. So P to Q is 3 root 5. I'll put it there. That's 3 root 5. Okay. So we now know what that is. You know what? I'm going to put this here actually. I'm just going to put it there. This is 3 root 5. Okay. Now we need the distances of PS and QR. Now we can find that very easily because we've got the vector Q to R. We don't even need the position vectors because we've got pretty much everything we need. Q to R, the vector, is equal to 9i plus 18j. which means that the distance of q to r is going to be the magnitude of that, which is going to be the square root of 9 squared plus 18 squared, which is going to be 81 plus 162, whatever that is. 9 squared plus 18 squared is 9 root 5, right? When you put the square root. So that's 9 root 5. Okay, let's just triple that. Okay, so that's q to r. So this distance here is 9 root 5. Now p to s, we know is 3 times q to r. So the magnitude have to be that same ratio as well. So it has to be triple as well. So that means that p to s, the distance of it is going to be 3 times 9 root 5, which is going to be 27 root 5. So now we've got everything we need. We've got A, 27 root 5. We've got B, which is 9 root 5. We've got the height, which is 3 root 5. So therefore the area is going to equal 1/2 times by A plus B. So 27 root 5 plus 9 root 5 times by the height, which is 3 root 5. Now you can just punch this into a calculator, we'll do it for you, but where's the fun in that? Let's do it without a calculator. So we've got 1/2, we've got 27 plus 9, which is 36. That's going to be 36 root 5. And then we've got times by 3 root 5. Okay, and then now those two, root 5 and a root 5, that will make a 5. So I'm going to put a times by 5 there to indicate that. And then we've got 1/2 of 36, which is 18 times by 3, which is 30 plus 20, 54. So it's 54 times by 5, which is 54 times 10 is 540. Half of that is 27 with a 0. It's 270. So the answer is 270 square units. Easy. Okay, so question 4 says, figure 1 shows a sketch of triangle ABD and triangle BCD. ADC is a straight line. Given that ADC is a straight line, BD is equal to x plus 3 centimeters, BC is equal to x centimeters, angle BDC is 30 degrees, angle BCD is 140 degrees. Part A says show that x is 10.5, correct to 3 significant figures for 3 marks. Now, x is over there, right, which is part of the triangle BCD. So what I would do is separate these two triangles, triangle ABD and BCD. Now, because of the fact that x is in that one, BCD, I'm going to just separate that triangle from the one on the left, which is what I've done over here. So this is the triangle that we're dealing with right now. We're trying to figure out what x is. Now, what topic comes to mind? They ask you to show what x is. So you need to solve an equation, right? Now, we have triangles. We've got lengths given to us algebraically. We've got angles. It's trigonometry. What in trigonometry? Well, what I like to do is this. I've got this angle here and I've got the opposite side. And I've also got this angle on that opposite side, right? This is a classic indicator of the sine rule. So you're just going to use the sine rule. A over sine A is equal to B over sine B and so on and so forth. So it's going to be x over sine 30. This is going to equal x plus 3 over sine of 140. And I just need to figure out what x is. So to do that, let's get rid of the fractions by cross multiplying. So it's going to be sine 140. That is the constant times by x. This is going to equal sine 30 times x plus 3. Now that's an exact value. I know that sine 30 is a half, so I can put that there. And then expand that. That's going to be 1/2 x plus 3 over 2. And then I'm going to have sine of 140 times by x, like that. And then now what I can do, just to make things nicer, I'm going to times everything by 2. So it's going to be, times that by 2, it's going to be 2 sine 140 times by x. And that's going to equal x plus 3, isn't it? So that way I can move the x over and then just factor out the terms. So I'm going to move this on to the next page. I think I've got the diagram for part B on there, so I'll have to move it down a bit. Just give me a second. Yeah, this is part B. So let me just move this down a bit, like there. And then I'll put this there. So that will go there. And then now we're just solving this, aren't we? So we're nearly done. Okay. So yeah, to get x now, I'm just going to move that x over there. So it's going to be 2 sine 140 x minus x is equal to 3. I'm going to take out an x because I want to isolate it. So it's going to be 2 sine 140 minus 1 is going to equal 3. That means that x is equal to 3 over 2 sine 140 minus 1. What is that equal to? So putting that in there. 3 over, 2 sine 140 minus 1 is equal to 10.5, isn't it? 10.505, which is 10.5 centimeters to 3 significant figures. So that's part A done. That will give you the 3 marks. Now part B, what does part B say? It says, given also that AD is x minus 2 centimeters, find the length of AB, given the answer to 3 significant figures. This is only 2 marks. So AD is x minus 2 and BD is x plus 3. So now we're going to deal with triangle ABD, okay? And we need to figure out what length AB, okay? So this is the diagram here. Let me just bring this up a bit and let me label everything just so we have it all. So, okay. So, what was that? I think this was A, that was D, and then that was B. I believe. So let me just check though. A, D, B, perfect. Okay. Now we're trying to figure out what A to B is. We now know what X is. X is 10.5, isn't it? So if X is 10.5, if X is 10.5, then X minus 2 is going to be 10.5 take away 2, which is 8.5, like that. And then this one's going to be 10.5 plus 3, which is 13.5, like that. So let me put this in the box because the other one's in the box as well. So that what that means is that I can remove these because I actually know what X is and put those there. Now we're trying to figure out what A to D is. A to B, sorry. How do we do that? Well, it would be great if we had the angle that's lodged in between AD and BD, this one here. Because if we did, then I always like to think of this as SAS when I'm teaching in GCSE. SAS, you could use the cosine rule to figure out what that side is. Now, are we able to calculate that angle? Absolutely, because in the original diagram, that angle is 30 degrees, which means that this angle has to be 150, isn't it? Right? Because angles on a straight line add up to 180. So I can say that that angle in the middle is 150, and then I'm good to go because I've got everything I need. So 150 degrees will go there. So because I've got everything I need, I've got two sides of the angle in between, I can use the cosine rule. So the cosine rule, we know, is a squared is equal to b squared plus c squared minus 2bc cos a. So all you need to know is that your a is going to be this side here. Let's just call this side y, right? The side that we're looking for is y. So we're going to put y squared here. Now b and c does not matter. You just need to know that it's always the two sides, either side of the angle, which is lodged in between. So it's going to be 8.5 squared plus 13.5 squared minus 2 lots of those same two sides. Cosine of 150 degrees. So you're just going to literally lodge that into your calculator and see what you get. So let me just zoom out a bit so you can see the working out too. Okay, so it's going to be 8.5 squared plus 13.5 squared, like that, minus 2 lots of 8.5. So it's going to be like that. And then that's going to be 13.5 like that. So let me just double check. 8.5, fine, fine. Cosine of 150 will go there. And then equals, that gives me 453.25, blah, blah, blah. So therefore, y, which is equal to a to b, is going to be the square root of that. Let me do it. Let me write that actually. That's going to equal, calculator, square root answer, 21.289, 21.289, which is approximately 21.3. 1.3 centimeters. And that is your answer. Let me move this here actually. Move this all here just so it's inside. And perfect. That is it. Yep. Perfect. It was in centimeters. It was perfect. Brilliant. That is question 4 finished. Let me just make sure I read it correctly. Yes, perfect. 21.3 centimeters. And that's it. Okay, so question 5 says the curve C1 has equation y equals 6 over x plus 3. Part A, I says sketch C1 stating the coordinates of any points where the curve cuts the coordinate axes. And double I says state the equations of any asymptotes to the curve C1. And this is all for 3 marks. Now, in this paper, we've got this little gap here, which I don't really see. So I'm assuming that this is where I'm meant to draw the graph. So I'm going to do it here. So I've just got it here. I've got the equation of the graph there. Now, whenever I'm sketching graphs, stuff like this, I always ask myself, well, is this a transformation of some sort? If so, what graph is the original? It's a division of x. It's the reciprocal graph, isn't it? So what you want to do is, first, I'm going to call this f of x, right? I'm going to firstly sketch 1 over x. What does that look like? Because once I know what that looks like, I can just use my transformation rules to get to the one that we need. So 1 over x, we know, is just like this, like that. This is 1 over x. Now, what do I need to do? I need to get 6 over x plus 3. Now, firstly, let's deal with the 6. If this is 1 over x here, what does that 6 do? Let's just say I put this here. 6 over x, so times of 6, so it's going to be 6 f of x, isn't it, right? If I times both sides by 6, I'll get 6 f of x. And what does that do? What does that 6 do to the graph? It stretches it vertically by 6, by a scale factor of 6. But the most important thing is that none of the asymptotes are going to be affected, right? Because essentially, the graph doesn't actually go through those points, those asymptotes, so it's not affected. Okay, so what I'm going to do is say if that's 1 over x like that, then I mean, if what you could do doesn't really matter, you could just kind of like do that, to be fair, just to make it like look like it's stretched out or something. Doesn't really matter though. So I'm going to set this is 6 over x, right? So I'm going to set this is 6 over x. Now, what do I need to do next? Because I've got a plus 3 there. I now need to get the plus 3. So if that's 6 over x, let me do it here. 6 over x plus 3. Well, what do we do? Well, we're going to add 3, aren't we? Which would mean it's going to be 6 f of x plus 3. That is what the graph actually is in terms of the original graph, 1 over x. What does that plus 3 do to the graph? It's on the outside of the function. It shifts everything upwards by 3 units. So what will happen is that this graph here, that part and that part will go up by 3 units, isn't it? Yeah, so let's just say it's like that. You know, I'm just going to bring this down a bit. It's a sketch, it doesn't matter. But yeah, it's going to look something like that, right? Now, what do we need to do? They said 2 things. We need to state the asymptotes and the point of intersection. Now, I think asymptote is easier because originally the graph of 1 over x had asymptotes on the x and y axis. So this is the y axis, that's the x axis. The y axis is the equation of line x equals 0. And the x axis is the equation of line y equals 0. Now, if everything is shifted up by 3 units, that horizontal asymptote at y equals 0 shifts up by 3 units as well. So instead of it being at y equals 0, which it was for the original graph, it's going to go up by 3. So the asymptote is going to be there, and it's going to be y is equal to 3. That is going to be the asymptote. Now, the point of intersection with the coordinate axes is right over here, right? That is when y is equal to 0. So all we need to do now to get that is just to set 6 over x plus 3 equal to 0. So doing that, let's times everything by x just to get rid of the denominator. That's going to be 6 plus 3x is equal to 0. Times everything by 3. Take the 6 over. 3x is going to equal minus 6. That means that x is going to equal negative 2. Minus 6 divided by 3. So this here is minus 2. So this here is your answer. Let me do it again. So it's just super clear. So it's going to look like this. It's going to look like this, like that. That's going to be y is equal to 3. And that is going to be minus 2. So that's it, like that. Hold on. Put this in. To be fair, I think the other sketch is better, but I'll just do it again just so it's super clear. And that will be your answer. Obviously do it a bit neater than me. But yeah, that is it. Done. Okay. So that's part A done. Part B, let's go to it. I think I'll do part B and then I'll do a separate vid for part C. Anyways, part B says the curve C2 has equation y equals 3x squared minus 4x minus 10. Part B says show that C1 and C2 intersect when 3x cubed minus 4x squared minus 13x minus 6 is equal to 0 for 2 marks. Okay, so there's a key word here in my opinion. It's intersect. How do we show two equations, excuse me, intersect? We equate them, don't we? Excuse me. So we have 6 over x plus 3, and we've got 3x squared minus 4x minus 10. If they intersect, then the y's are going to be 0. So we can equate them and then obviously just use algebra to get it in that form. So I'll do it for part B, huh? So for part B, we have y is equal to 6 over x plus 3. And the other one was y is equal to 3x squared minus 4x minus 10. It's curve C1, that's curve C2. If they intersect, then the y's are going to be equal. So I'm going to literally equate them. I'm going to put this one on the left. So 3x squared minus 4x minus 10 is equal to 6 over x plus 3. Okay? Now we need to show that they intersect when we have that equation there. So all this is a matter of is just using algebra to get it into that form. So what I'm going to do first is I'm going to multiply everything by x to get rid of that division of x on the right hand side. So if I times everything by x on this side and on that side, then it's going to be 3x cubed minus 4x squared minus 10x. And this will equal just 6 because the x is cancelled plus 3x. Like that. And then now that just means that 3x cubed minus 4x squared. And then if I move that over, that plus 3x will become a minus 3x. So it'll be minus 13x. And then that will be a minus 6 is equal to 0. And that is it. Let's just check. Yeah, 3x cubed minus 4x squared minus 13x minus 6 is equal to 0 as required. So that's part B. So that's part B. I think I was going to do a separate video. I'll do a separate one because I'm going to really break it down. So yeah, that's part B. Let's go to part C. Okay, so part C says, given that the x-coordinate of one of the points of intersection is minus 2/3, use algebra to find the x-coordinates of the other points of intersection between C1 and C2. Solutions relying on calculator technology are not acceptable. And this is a 4 marker. I have got part B here as well because as with a lot of these questions, they want to scaffold it to help you access the marks. Okay, so what you did in part B may be applicable or may be related to what you're doing in part C. What does part B say? It says show that C1 and C2 intersect when you have that equation there, 3x cubed minus 4x squared minus 13x minus 6 is equal to 0. So this is our point of reference here, this equation. And the first part of part C says that given that the x coordinate of one of the points of intersection is minus 2/3, right? What does that mean in the context of what we're dealing with? We've got a cubic, right? We know that we're trying to find the x coordinates of the other points of intersection. So we're looking for the roots. We're looking for the solutions to this equation, right? We're dealing with a polynomial. How do you find the roots of a polynomial? Well, you need to factorize it. What comes to mind? Given that the x coordinate of one of the points of intersection is minus 2/3. Well, for me, if I was to call this f of x, right? Let's say I call this f of x, right? That means f of x is going to equal 3x cubed minus 4x squared minus 13x minus 6, right? Now, if the x coordinate is minus 2/3, then that's just telling me that when I plug in minus 2 over 3, right, into this function here, I will get 0 out, isn't it? Because one of the x coordinates of intersection is minus 2/3, right? And it satisfies this equation here. What comes to mind, guys? I want you guys to pause the video for a moment and ask yourself, what comes to mind when I see something like this? I'll give you about 5 seconds. Okay, well, the answer is the factor theorem, isn't it? Remember, these types of questions, they like to bring different parts of different areas of maths and bring it all together. This is a factor theorem question because if I plug in minus 2/3 and I get 0, then that just tells me that x plus, I should say plus 2 over 3, right? Essentially is a factor like that. But we don't want it like that, do we? So what I'm going to do is I'm going to write like this. I'm going to write x plus 2 over 3 is equal to 0, right? Because x plus 2 over 3 is a factor. So that must be 0. And then I'm just getting to the form that we know. So if I times everything by 3, then it's going to be 3x plus 2 is equal to 0, isn't it? And I'm going to use this here. So what I'm going to do is I'm going to use algebraic long division to figure out what the quadratic factor must be. Once I've got that quadratic factor, I can factorize that and then I get the other two roots. So this is the type of things that you need to do in an exam. And I really like this question a lot because you really need to think outside the box and you really need to have a good understanding of just all of the areas of maths in terms of long division and factor frames and so on and so forth. So again, what are we looking for? The other points of intersection. So we're going to use long division to figure out what the quadratic factor must be. So I'll do it on this page here. So the factor is 3x plus 2. 3x plus 2. And I'm going to divide this here. I don't need that bracket, to be fair. Like that. And what was the cubic again? It was 3x cubed minus 4x squared. 3x cubed minus 4x squared. And I believe it was minus 13x minus 6, but I'm going to just double check that. Yeah, perfect. Okay, so now we need to just use long division. So this is not too bad. So how do we go about doing long division? So remember, you're going to get this term and you're going to divide it by that term there. So it's going to be 3x cubed over 3x. That will be cancel. That's just going to be x squared. So that x squared goes there. And then we're going to multiply x squared by the actual factor, which is 3x plus 2. And that will be 3x cubed plus 2x squared. So that will go there. So 3x cubed plus 2x squared. And then we're just going to take these away, aren't we? So take away, take away. Let me just read this here. Get rid of those. So then that's 0. Minus 4 minus 2 is going to be minus 6. So minus 6x squared. Bring the minus 13 down. And that, repeat the process. So with the minus 6x squared, we're going to divide it by the 3x. That's going to be minus 2 x, isn't it? So that will go there. And then now repeat the process. We're going to do minus 2x times by 3x plus 2. That's going to be negative 6x squared. And that's going to be a minus 4x, isn't it? Yeah. Minus 6x squared minus 4x. Take these away. That will become 0. Minus x squared minus x squared that becomes 0. Minus 13 minus is a plus. So minus 13 plus 4 is a minus 9. So that's going to be minus 9x there. And then bring the minus 6 down. Repeat the process one more time. So minus 9x divided by 3x. It's going to be minus 3. That goes there. And then obviously we're going to just times it just to make sure we get no remainder. So minus 3 and then it's going to be 3x plus 2. That's going to be minus 9x minus 6, which is the same as that. So when I do that, I get 0 when I take these away. So therefore, there's no remainder. So this here is going to be our factor when we divided the 3x plus 2 by that cubic. So therefore, we can say then that f of x, right, the cubic function, is actually just the same as 3x plus 2 multiplied by x squared minus 2x minus 3. So now all we need to do is factor this quadratic here to get the other roots. So factor in that. Let me just put this here again. Okay. We need two factors of negative 3, which are going to add to make negative 2. That's going to be a negative 3 and a positive 1, isn't it? Yep, that's fine. So therefore, the two other roots are going to be when x is equal to 3, make that 0, x equals minus 1. What did the question ask us for? It says use algebra to find the x coordinates of the other points of intersection of C1 and C2. Yeah, so this is it. X equals 3, x equals, let me just write so it's clear. Other points, other x coordinates of intersection, because it didn't ask for the actual coordinates, so I don't need to plug in to find out what y is. So other x coordinates are x equals 3 and x equals minus 1. And that is it. That is your answer. And that's the question finished. Okay, so question 6 says the binomial expansion of 1 plus ax to the power of 12 up to and including the term nx squared is 1 minus 15 over 2x plus kx squared, where a and k are constants. Part A says show that a is equal to minus 5/8 for 2 marks. Okay, so firstly, we've got the expression here, 1 plus x to the 12, and they've told us that up to the x squared term, we get this here. So what I like to do is I'm going to make this equal to what they've told us it is, right? 15 over 2 x plus kx squared up to and including the x squared term. Now, because these are the same thing up to the x squared term, I want to use the binomial expansion formula to get the expansion for this, and then I'm gonna obviously equate it to the one on the right. And then you're just gonna use you're just gonna compare coefficients to figure out what A is for part A and then K in part B. So it's very, very straightforward. So let's do that here. So part A, what is the binomial expansion formula? It's A plus B to the power of n is equal to, start off with A to the power of m plus, and then it's gonna be n, choose one, and then times by a to the power of n drops by 1, so n minus 1, and then b comes to life, so b to the power of 1, and then nc2 for the next term. Again, power of a drops by 1, and then the power of b increases, doesn't it? So it'll be like that. Now I'm only going to go up to here because I only need it to the square term for the x. So now it's just a matter of plugging this in, isn't it? So it's 1 plus ax, isn't it? So 1 plus ax to the power of 12. So just using everything we have here. So it's going to be 1 to the power of 12, right? You know what I'll do actually, just so it's super clear. I will label what a is and everything. So I'm going to say that a is going to equal 1, as we can see there. B is going to equal ax, and n is going to equal 12, isn't it? Now I'm going to use the formula. So it's going to be equal to 1 to the 12, 1 to the n, plus 12, choose 1, and then it's going to be 1, let me put a bracket around here, 1 to the power of 11, power drops by 1, and then b is ax, so ax to the power of 1, plus 1 to the, no, not 1, nc2 now, so 12c2, and then 1 to the 10, and then b, which is ax to the power of 2. And now it's just a matter of expanding that and seeing what we get. So doing that, that's 1 to the 12 is 1. 12c1 is just 12, isn't it? nc1 is always n. So that's going to be 12. 1 to the 11 is 1. So it's 12 times 1, which is 12 times by ax. So that's just 12ax, isn't it? So that's just 12ax. And then plus, and this one I'll put in the calculator. 12c2, 12c, 12c2 is 66. So it's 66 there. And then 1 to the 10 is just 1, so I don't need anything there. And then this here is a squared x squared, isn't it? A squared x squared. So that's going to be 66a squared x squared. Perfect. Perfect. Now we know that this here is equal to that there, 1 minus 15 over 2x plus kx squared, isn't it? So let me just copy this there and put this there. Now remember, we're trying to find out what a and k is, so we just need to equate coefficients, don't we? So, whoops, where's my rubber? Okay, so equating coefficients now. Well, for a, if I look at the a term there and there, I can say that 12ax is going to equal minus 15 over 2x, isn't it? So that means that the coefficient 12a must equal the coefficient minus 15 over 2. So I'll do it here. 12a is going to equal minus 15 over 2. I need to figure out what a is, so I'm going to divide by the 12. So that will be a is going to equal minus 15 over, if I divide by that 12, then I times the 12 by the 2 on the bottom, so it becomes 24, isn't it? Let me just write divided by 12, so it's super clear what's happened there. Or you can just put it into your calculator, and then that is just equal to, divide top and bottom by 3, that's minus 5, that's 8. So therefore a is minus 5 over 8, which is what they wanted, so that's done, perfect. Part B says, hence find the value of k. So to find k, we're just going to do the same thing for the square term. Let me move this here. I can do it all on this page actually. So I'm going to move this here, and I'm going to do the other bit here. So now I'm going to do this one. I'm going to do that there and that there, like that. So the coefficient for the x squared term on this side is 66a squared, isn't it? Remember, a is a constant, so 66a squared is the constant there, and this must equal k. So therefore, I can say then that 66a squared has to equal k. I now know what a is. I mean, not now because it was a show that, to be fair. And that just actually gets me thinking. Remember, guys, if you can't do a show that, then that doesn't mean you can't do the next part of the question, because it says show that a equals minus 5 over 8. So you could still technically do, you can still technically find k, but I mean, if you can't, if you can do, I mean, I'm just trying to think. With this one specifically, If you can't do part A, which is the expanded part, you still may find K a bit tricky. But anyways, um, let's plug it in. So A is minus 5 over 8. So it'll be like that, isn't it? Squared, and then that will equal K. So therefore K is equal to whatever that is. So let's put it in the calculator. 66 times minus 5/8 all squared. That is 825 over 32. So that is it. A is minus 5/8 and K is 825 over 32. So that is part A and B. We're going to go into part C now. Okay, so part C says, using the expansion and making your method clear, find an estimate for the value of 17 over 16 to the power of 12, given your answer to 4 decimal places. Okay, and what I've got is I've just got summarized what we did in part A and B. We got A equals minus 5 over 8 and K is equal to 825 over 32. And remember, I made the expression on the left equal to that on the right, and you'll see why. So we're dealing with binomial expansion. We're asked for an estimate, aren't we? Now, you just need to remember the whole concept and idea of binomial expansion, as well as being able to use a formula to get a polynomial expression, such as this one here. You can actually use it to find numerical values, or I should say, estimate or approximate numerical values. And this is a very powerful tool, and it was used very long time ago before calculators even existed. Mathematicians used to use this to approximate powers, roots, and even logarithms. Okay, so how does it actually work? Well, what I'm going to do is I'm going to write this all out. So it's 1 minus 5 over 8 to the power of 12. Keep forgetting that x, right? To the power of 12. And then this is going to be approximately equal to 1 minus 15 over 2 x plus kx squared up to and including the x squared term. So what does this actually mean here? Well, if we have 17 over 16, I'm going to write this here, 17 over 16, and that to the power of 12, is there a connection here? Absolutely. Is there a value of x, right, that I could plug into this that will give me 17 over 16? Because if there is, that value of x, I could plug it onto this side, and then that should give me an approximation for 17 over 16 to the power of 12, which is what we want. Well, how do we go about doing this? Well, all you're going to do is just equate these, aren't you? All right, let's equate them and see what we get. So we're going to have 1 minus 5 over 8x is equal to 17 over 16. I need to solve that. So that would mean that I'm going to have, let me times everything by 2 just to solve it very quickly. To 16, sorry, to get rid of the denominators. So that's going to be 16 minus 16 times 5, 8. 16 over 8 is 2. That's going to be a minus 10x, and that's going to equal 17 because they cancel. That means that 16 minus 17, which is minus 1, is going to equal 10x if I put that on the right. And that just means that minus 1 over 10 is equal to x. So the value of x, which will allow this bracket, the thing inside the bracket, to be 17 over 16, is minus 0.1. Now, how does that help us? We can now plug that into the right, can't we? So let me put this here now. I'm going to say x is going to equal minus 0.1, right? Then I'm going to plug that into there. And that will give me an approximation for 17 over 16 to the power of 12, wouldn't it? So put that in there. Plus, and then k. Yeah, we know what k is, isn't it? So let me move that out of the way. K is 825 over 32. Forgot to put the k in. But yeah, that's fine. Like that, and then that's going to be minus 0.1 all squared. So I'm going to put this into the calculator and see what I get. And what I will do first, let's actually calculate what 17 over 16 to the power of 12 actually is, just to see if we're along the right track. So we get this there. It's 2.0699 to 4 decimal places, isn't it? So basically to 2.07. So let's plug that in and see what we get now. So it's going to be 1 minus 15 over 2 to the times by minus 0.1 plus 825 over 32, and then minus 0.1 all squared. That is 257 over 128. Now, what is that actually equal to? Let's have a look. If I press SD, I get 2.0078125, which is very, very close to that number. So this is definitely a good answer for sure. So therefore we can say then that an estimate, all right, estimate to 4 decimal places is going to be 2.0078, isn't it? 1, 2, 3, 4. 1, 2, 3, 4. Yeah, perfect. And that is it. That is essentially how you calculate an estimate with these types of questions. Brilliant. Okay, so question 7 says a chimney emits smoke particles. On a particular day, the concentration of smoke particles in the air emitted by this chimney, p parts per million, is measured at various distances, x kilometers from the chimney. Figure 2 shows a sketch of the linear relationship between log base 10 of p and x that is used to model this situation. The line passes through the point 0.3 and the point 62.1. Part A says find a complete equation for the model in the form p equals ab to the x, where a and b are constants. Give the value of a and the value of b, each to 4 significant figures, and this is a 4 marker. Okay, so with this question here, there's a couple ways to do this. So what I'm going to do is label this, right? Remember, we have a set of axes here, a horizontal and a vertical one. The horizontal one is x here, and then the vertical one is your y-axis, isn't it? Now, it's a linear relationship, so it will still follow the general formula for the equation of a line, which is y is equal to mx plus c, right? Now, when I look at our axes here, the vertical axis isn't y, it's log base 10 of p, isn't it? So I'm going to say y is equal to log base 10 of p. And obviously x is still x, so that's fine. So that means that if I was to use that, it would be log base 10 of p is equal to mx plus c, right? Now, what we need to do in this form is figure out what m is, the gradient, figure out what the y-intercept is, and then plug it into this formula. Once I have that, I can use a bit of algebra to get rid of the logs and get it into this form. And then that will give us a and b when we compare it. So let's do it that way and see how we get on. So firstly, because I've got this formula, I want the gradient. How do I find the gradient? The gradient is just difference in y over the difference in x. So if I do that, then the gradient in this case, I will do it this way. So I'll call this x1, y1. I'll call this x2 and y2. It's going to be y2 take y1, which is going to be 2.1 minus 3.3 over 6 minus 0. And that will give me, that will be negative, isn't it? 1.2 over 6, which is just 12 over 6 is 2. This is 0.2, isn't it? So the gradient is minus 0.2. So I'm going to put that in there. Log base 10 p is going to equal minus 0.2x plus c. Now I need to figure out what c is. Well, c quite clearly is just the y-intercept, which is 3.3. So I can rub that out. And you know what? I won't rub that out. I'll just write this. All right, c is equal to 3.3 from the coordinate 0, 3.3. So that means then that log base 10 of p, log base 10 of p is equal to minus 0.2 x plus 3.3. So now I've got that, what I can do is use algebra to get p on its own, and that will allow me to figure out what a and b are. So we are here, we've got everything we need. So I'm going to zoom in a bit, and then now I need it in that form, p equals ab to the power of x. So how do I go about doing that? Let me just, I'm just zooming a bit more. Yeah, that's perfect. Okay, let me put this here. All right, and then I'll just go up a bit because I need that format, don't we? Okay, so yeah, that's fine. Or you know what, I'll just write it. P equals AB to the X. I'll zoom in and just write it, that's fine. So P is equal to AB to the X. That's what we want. So what am I going to do to get that? I need to get rid of that log. So I'm going to raise both sides with whatever base this is. That's a 10. So I'm going to raise it like this. 10 there and a 10 there. Those cancel. So it's going to be P is equal to 10 to the power of minus 0.2x plus 3.3. And then now, what I can do is use my index laws. Because these are adding, I can split them into a product. So it's 10 to the power of minus 0.2 times, sorry, x there, times by 10 to the 3.3. And then I can work out what 10 to the 3.3 is. That's going to be 10 to the power of 3.3 is going to be 1995.26. So that there is going to be 1995.262 blah 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 times by, and then this right here I can use my index laws because it's minus 0.2x. It's a product. I can put one of them in and other on the outside. So it's going to be 10 to the minus 0.2 to the power of x, isn't it? Right? Just from my index laws. And then now I can work out what that is. So that's going to be 10 to the minus 0.2 like that. And then that's going to be P is going to equal 0.6, what was that? 3095 to the power of x times by 1995.262. So now this is easy. We just need to write it to four significant figures now. So it's going to be P, and then the first term is going to be that number there. To four significant figures, that's just 1995. And then B is that number there. To four significant figures, that's 0.630. That's going to be 0.6310, isn't it? So it's going to be 0.6310 to the power of x. So we can see quickly that's our A, that's our B to the power of x. So therefore A is going to equal 1995 and B is going to equal 0.6310. And that is it. That is part A done. So that's one way of doing it. I think there's a quicker way, and I'll do it in a separate video. So I'll stop it off here. Okay, so the second way you can do this question, I think this is probably the more preferred way, or the preferred way, the more efficient way, is you actually start off with the equation and then you use logs to get it in the equation of a line form. So I'll show you how that works. So you're gonna start off with this one here. You're gonna take logs of both sides with base 10. So it's gonna be log base 10 of P is going to equal log base 10 of AB to the power of X. And then essentially you want to get into form of Y equals MX plus C. So we're going to split the right hand side using the log laws. It's a product, so we can split this like that. A plus log base 10 of B to the power of X. And then what we're going to do from here is another log law. We've got a power that x can drop to the front, isn't it? So we have this here like that, don't we? Now to get in the format that we want it in, I'll do it here. It's going to be log base 10 of P. It's going to equal log base 10 of B, and I'll put this in a bracket and you'll see why. I put x there plus log base 10 of A. Now, all I've done here is this is a bracket, isn't it, right? This is a number. I've just put on the left and I put the x on the right. Now, the reason why I'm doing that is because if I was to compare this, it would be y is equal to mx plus c, right? Now, that tells me that whatever the log base 10 of b is, that's going to be your gradient. And whatever log base 10 of a is, that's going to be our y-intercept. Now, we can use that to figure out what A and B are very easily because remember, we know what C is. C is 3.3. So I can say then from there that log base 10 of A is just equal to 3.3. And then the gradient we worked out to be minus 0.2, isn't it? So we can now say from there that log base 10 of B has to equal minus 0.2 because that is C and that is M. Okay? So now it's just very, very easy because that equation there, I'll write them here actually. We'll write them here and just solve them. Whoops. Solve these over here. I think this is an easier way to do it, to be honest. Put these there and I'll just solve these very, very quickly. So let me wrap this out. So solving this one, how do we solve that? You're just going to raise both of these with a base of 10 to get rid of the log. So it's going to be A is equal to 10 to the 3.3. And then this one is going to be b is equal to 10 to the power of minus 0.2, which we worked out already, isn't it? That one was what was 10 to the 3.3? That was that one there, 1995, isn't it? To four significant figures. And that one was 0.6. Was it 310? Yeah, 310. And that is it. That is the other way to do it. Let me know which way you guys prefer in the comments. I believe it's the second way. But yeah, I just thought to do both. So that is part A done. Let's do part B. Part B says, with reference to the model, interpret the value of AB. Okay, so let's get that. Put this, there's only one mark. So you want to just use context, don't you? So remember what we figured out, by the way. In the first part, part A, we figured out the full model. We figured out what A and B are. So the actual model is P is equal to AB. A is 1995 times by B, which is 0.310 to the power of X, isn't it? Okay. Now we want AB. Let me write this here as well. P is equal to AB to the power of X. Now, algebraically, how can I get the expression AB? Well, if X was equal to 1, I would have P is equal to AB to the power of 1, which is just AB, isn't it? So we get AB when X is 1. That's the main thing. So I'm going to write this here. When X is equal to 1. Now we know how we get the expression AB. We need to interpret it in context, okay? So what does that mean? Well, when X is equal to 1, well, what is X? What is P? X is defined as the distance from the chimney. X kilometers from the chimney. So X equals 1 is 1 kilometer from the chimney. What do you get when X equals 1? You get P, which is in parts per million, which is the concentration of smoke particles in the air emitted by the chimney. So what you're going to say then, to interpret the value of AB, it's going to be the concentration of smoke particles emitted by the chimney in parts per million. Write this here. I don't know why I'm not writing it here. So in parts per million. In parts per million. Yeah. At a distance of 1 kilometer from the chimney. Something like that. And that will give you the 1 mark. So that is part B. So the concentration of smoke particles, I wrote particles, sorry. I'm a maths guy. The concentration of smoke particles emitted by the chimney in parts per million at a distance of 1 kilometer from the chimney. Let's just read it again. So on the particular, the concentration of smoke particles in the air emitted by the chimney in parts per million is measured at various distances, x kilometers from the chimney. Yeah, so that's fine because x equals 1 represents the distance of 1 kilometer from the chimney, and P is the concentration of smoke particles. Perfect. That is it, and that is question 7 finished. Okay, so question 8 says, figure 3 shows a sketch of the curve C with the equation y equals x cubed minus 14x plus 23. The line L is the tangent to C at the point A, also shown in figure 3. Given that L has equation y equals minus 2x plus 7, part A says show using calculus that the x coordinate of A is 2, and this is for 3 marks. So I've just got it summarized down here, so we don't need to keep going up and down. So what are we doing? We're trying to show using calculus. This is very key. We need to use calculus here. Where's my pen? We need to use calculus here. To show that the x coordinate of A is 2. Now, A is the point where the line L is a tangent to C, right? So remember, whenever you see that word tangent, guys, in an exam, right, it just means to differentiate, right? So what I'm going to do is I'm going to differentiate the function. So y is equal to x cubed minus 14x plus 23. That means that dy over dx will equal 3 will drop to the front, 3x squared minus 14x. Sorry, minus 14 because the x will go and the 23 will disappear. So that's our gradient function. Now remember, when you're dealing with a gradient function dy dx, You plug in values of x, and that will give you the gradient of the tangent at specific points, right? Depending on what x value you choose. Now, we know the equation of line L. Line L has an equation of y equals minus 2x plus 7. Now, this gradient here, minus 2, is found from the dy dx on the top. You plug in a value of x, and that will give you something out. In this case, it must be minus 2. So what we want to do is actually equate the equation or the dy dx expression to minus 2, because there's a certain value of x that when I plug it in, it will give me minus 2, which is how we get that equation of the line for L, right? So I'm going to solve this. So doing that, I'll do it here. It's going to be 3x squared. Add the 14 over, that'll be a 12. Divide by the 3, that'll be a 4. Square root, we're going to have plus or minus 2. So x either equals plus or minus 2. Now remember, we're looking at the point A. If you look at the diagram, point A is it's in the first quadrant, isn't it? Positive x-axis. So x is 0 there. X is greater than 0 there. So I can say at A, x is greater than 0, right? Therefore, x equals 2 and not minus 2, right? Just to be super, super clear for the examiner. Perfect. So that is part A done. Now part B. It says the line L cuts C again at the point B. Verify that the x coordinate of B is minus 4. So that there is minus 4 apparently. We need to verify. Now, this is a good question because in part A, it was a show that was showing something. In part B, it says verify. They mean different things. I remember when my teacher taught me this when obviously I was you guys' age, and she was like to me, verify, you just substitute, right? You don't need to use algebra. So we're verifying that the x coordinate of B is minus 4. B is the second point of intersection, isn't it? Right? We've got two things. We've got a line L and a curve C. They intersect at 2 points A and B. We've shown using calculus that the x coordinate of A is 2. We need to verify that the other point of intersection is minus 4. So we don't need to do any algebra here. We just substitute. So the line L, we know, is minus 2x plus 7. Now, if it cuts, right, then that's another word for intersection. So we're going to equate it. And the curve C was x cubed minus 14x plus 23. X cubed minus 14x plus 23. If they cut, then this must be the equation for it, right? We just equate both of them, the line and the curve. Now, all we're going to do now is substitute minus 4 into the left-hand side and the right-hand side. Once we do that, if they do cut at that point, then they should be the same. We should get the same thing for the left and the right. So let's plug in x equals minus 4. Let's plug in x equals minus 4 into the left-hand side. It's going to be minus 2, lots of minus 4, plus 7. That is going to be equal to, that's going to be 8 plus 7, which is 15. So now we've done that, what we should hope for now is if we plug in minus 4 into the right-hand side, we should get the exact same result. We should get 15. So minus 4 all cubed times, sorry, minus 14, lots of minus 4, plus 23. So doing that, that's going to be negative 64. That's going to be 2856. And then that's going to be plus 23. What's that? That is 8 minus 8, no? What's that? 15. Perfect. So therefore, what we can say now is that the left-hand side is equal to the right-hand side, right? Therefore, x coordinate of B is minus 4. And that's it for part B. Perfect, finished. Okay, so part C says the finite region R, shown shaded in figure 3, is bounded by C and L. Using algebraic integration, show that the area of R is 108 for 5 marks. Okay, so whenever you're doing these types of questions, guys, look at the diagram, visualize it. We're looking for an area. You want to see the question, you want to see the picture. So the area of R, as we can see, is a big part of that area underneath the curve, isn't it? Now, the fact that we said algebraic integration should be a hint, right? That you're obviously you're gonna need to integrate. You're gonna need a definite integral. So what I like to do before I actually start calculating areas is actually to visualize what area it is I'm calculating, especially with a shaded area, which you're gonna find more often than not by removing one area from the other. Okay. So firstly, if I get an axis going, by the way, I've got a new update on this OneNote app, so I'm still getting used to it. It's going to be here, isn't it? Which I'm sure you guys probably noticed when you looked at question 7 and went to question 8. Anyways, if I was to draw a rough sketch of this curve, it's going to look something like that, okay? This is point B, right? Which we know is -4. That's -4 over there. Point A is 2. Now, that area, if I was to just get a highlighter and just highlight all of this here, right? All of this here. Now, I could calculate this area, couldn't I? Right? This area is just going to be the integral of the curve between the two limits, -4 and 2. However, I don't want that as my final answer because as you can see from the diagram, there is a part that's cut off, isn't it? Which is underneath here. So what I would need to do to calculate that region R, I would actually draw it. So it's going to be that part, which looks something like that. This is the area that we're trying to calculate. This is going to equal the area of that whole thing, which is going to look something like that. And then we will take away that area underneath, which happens to be a trapezium, isn't it? Yeah. So this is our answer. The region R is worked out by finding the area of that thing, which is going to be the integral of C. I'll just write C dx, and then the area of this trapezium. So we work out both of those, take them away, and we're done, right? So now we need to calculate that area. So we need to integrate. So I'm going to get this here, and I'm going to just I'll put integral sign here. We're going to integrate between -4 and 2. So -4 and 2. And then we need to integrate the curve. The curve was x cubed, wasn't it? -14x plus 23. Perfect. Okay. So that is going to be x cubed minus 14x plus 23 dx, right? Now, how do I integrate that? We just add 1 to the power, divide by the new power. So it's going to be equal to, I'll do it here, a quarter x to the power 4. That's going to be x squared divided by 2. It's going to be a 7 at the front, isn't it? 7x squared, right? Because when we differentiate that, we get 14x. That's fine. And then plus 23x. And we're integrating this between -4 and 2. So all we need to do now is just evaluate the limits, isn't it? So we're just going to plug these in. So it's going to be equal to a quarter 2 to the power 4 minus 7 lots of 2 squared plus 23 lots of 2. Take away the lower limit now, put in a big bracket, a quarter minus 4 minus 7 lots of -4 all squared. I forgot the 4 there. Plus 23 lots of -4, like that. So I'm just going to put this to the calculator and see what we get. So that will give us a big part of this question done. Let me zoom out a bit just so we can see everything. So it's going to be a quarter. Whoops, quarter times 2, like that. 4 minus 7 2 squared, like that. That's fine. Plus 23 times by 2. And in the exam, I think you should always just break it down. So we get 22 there. So it's going to be 22, take away. And then the next part, we're going to just change these to -4s, aren't we? So -4, -4 there, and a -4 there. And that gives me -140. So therefore, that's 100. That's 22 plus 140, which is 162, isn't it? So that is that area. This area here is 162 square units. So now I've got that. I can actually put 162 there. 162 there. Now I need to calculate the area of that trapezium. Now, how do I go about doing that? Well, I need the dimensions of it, don't I? So from our diagram, we know that this was -4. That was a 2. So the base of it is 6. That's fine. So that's a 6 there. What else? We need the heights, don't we? Now, how do I get that height? Well, if I look at the diagram, remember, this is coordinate geometry, right? That point A, we know has an x coordinate of 2. This point B has an x coordinate of -4. the vertical heights are just going to be the y coordinates at those points, isn't it? Now remember, the points A and B intersect at the curve and the line, don't they? Right? So what we can do to figure out those points is you could either, if you want, you could either plug it into the curve, which was y equals x cubed minus 14x plus 23, or you could plug it into the curve, into the line, sorry, which was minus 2x plus 7, wasn't it? Either one of these, let me just make sure I've written those two correctly. Yeah, that's fine. The line L was minus 2x plus 7 for sure. Perfect. So you can either plug it into either one of these. So if I plug in x equals 2, I'm going to plug it into L, right? So I write C there, I write L there. If I plug it into L, the y coordinate will be from x equals 2. I'll run x equals 2. It's going to be y is equal to minus 2 lots of 2 plus 4 plus 7, sorry, which is going to be minus 4 plus 7, which is going to equal a positive 3. So therefore, that y coordinate there is y is equal to 3, which means that that's a 3 over there. And then this one is when we plug in minus 4 in, right? So we already did this actually in part B. Minus 4, that was just 15, isn't it? Because we verified that the coordinate, x coordinate of B is minus 4. So we already plugged in minus 4 into both of them and we got 15. So we don't actually need to do it again. Yeah, we know for certain that the y coordinate is 15, which would mean that this y coordinate right here is 15. And that would mean that this here is 15, isn't it, over there? So therefore, the area of that trapezium, I'll do it here. I'll draw the trapezium again just here, so it's super clear. So do it like this here, like that. This is 15. This is 3. That is 6, isn't it? So therefore, the area of that is going to be equal to 1/2. A plus B is going to be the 15 and the 3, isn't it? 15 plus 3 times by the 6. What's that? That's a half times 18 times 6. That is 9 times 6, which is 54. So therefore, the total area, remember, I'm going to write total area. Total area is going to equal 162 minus 54. 162 minus 54. Got a column method. 2 take away 4. We can't do borrow 1. Put a 1 there. 12 take away 4 is 8. 5 take away 5 is 0. Put a 1 there. 108. That's exactly what they wanted, isn't it? Yep, right here. Perfect. Show that the area of R is 108. So we did it. And that's it. Question 8 finished or finito. Okay, so question 9 says P is equal to log base A of 16 and Q is equal to log base A of 25, where A is a constant. Find in terms of P and or Q, part A, log base A of 256 for 1 mark. Okay, so whenever you see these types of questions, guys, whereby they give you two equations of logs, right, and they want you to get it in terms of something else, in this case P and Q, you essentially just want to use what they've given you as your point of reference, right? So I can see I've got a 16 there and I've got a 25. I want to use this as a point of reference. This type of question came up in 2023, the A2 paper, the actual A-level exam. I think it was paper 1. I can't remember what question, maybe 6, 7, or 8. It was towards the beginning. But I'll definitely recommend having a go at that one after this one as well. But yeah, you just want to basically use these as points of reference. So the first one, I'll do part A here, is 256. That's the number I have there. Now look at my two options, 16 or 25. Well, 256 and 16 are both even numbers. So I'd ask myself, well, how many times does 16 go into 256? So the first thing I'll do is get my calculator and be like, okay, well, let's work that out. 256 over 16 is 16, right? So it's 16 squared. 16 squared is 256. So what I'm going to do then is I'm going to say, well, log of base A of 256 is the same as log of base A of 16 squared, because 256 is 16 squared. And this is great now because I've got that 16, which we have in P, right? Now, from here, it's just log laws. I've got a power here. We know that from our log laws, the power can drop to the front. So it becomes 2 and then log base A of 16. And then now when I look at this here, well, I've seen this before. This is what P is equal to. That is P. So therefore, it's just 2P. And that is part A, done. Part B. Now, same thing. Log base A of 100. And I look at that, log base A of 100. Again, you want to use your two numbers as reference, P and Q, 1625. Well, I know that 25 goes into 100 4 times. So I can actually just say that log base a of 100 is the same as log base a of 25 multiplied by 4, right? And then now we have a product inside a log. We can use our log laws to separate them into a sum. So it becomes log base a of 25 plus log base a of 4. And then now looking at these two, well, I've seen that before. That's a Q. Now that one I haven't seen. However, it's not a big deal because we've got a 4 there. There's a 16 there. So what can I do? Well, I need to essentially use a bit of algebra to rewrite this. So 16 we know is the same as 4 squared, or 4 is the same as the square root of 16, which we're going to use instead actually because we need a 16. Our point of reference is 16, not 4. So what I'm going to do then is I'm going to say that this right there, this is the same as log base a of the square root of 16, isn't it? Right? The square root of 16 is 4, so we can do that. Now, what we can do from here is we can say that again from our index laws, that is 16 to the power of 1/2. And then now we can drop that half to the front. So it actually just becomes 1/2 of log base a of 16. And then now from here, remember, this here we know that is p. So therefore, we've got 1/2 times p. So all in all, I'll do it here. All in all, it becomes log base a of 25 we know is q, plus log base a of 4, which we figured out is just a half log a of 16, which is p. So therefore, it's q plus a half p. And that is it for part A and B. We'll go into part C now. Okay, so part C says find log base A of 80 times by log base A of 3.2, right? In terms of P and or Q. Now this one here, you don't want to get tripped up immediately. We've got a product in the middle of these two. There's nothing we can do here. You may be thinking of your log law, log A times B, which is equal to log of A plus the log of b, right? This is the log law. You can see there's a plus in the middle. There is a product here, a multiplication. If that was a plus, then you could combine them. So that is one thing just to point out. So again, when you're doing these types of questions, your points of reference, right? 16 and 25. What I'm going to do is have a look at these numbers 80 and 3.2 and see if I can write them in terms of 16 and 25 or factors of it, right? Because with the factors, you can just manipulate quite easily. Now 80, immediately, I know that that's 16 times by 5. So I can write this as log A, and then 80 is going to be just 16 times by 5, isn't it? That is fine. 16 times 5 is 80. Now multiplied by. Now immediately when I look at this, the first thing that comes to mind is 32 divided by 10, right? So I'm going to write as 32 divided by 10. Now when I look at this though, this is a fraction that can be simplified. We can divide top and bottom by 2. So it actually just becomes log base A of 16 divided by 5, right? And we've got this here. 16 times by 5. So this is where we're at so far. And as we can see, there's a bit of symmetry here, right? In terms of the numbers, 16 and 5, they're the same numbers there. And then we've just got a division and a multiplication. So there's a lot of symmetry going on here. I'm sure that will be apparent when we see our final answer. So what do we do? Now that we've got to this position, we can now use the log laws that we know because we've got a product here, so we can split this into a sum. We've got a division here, we can split this into a subtraction. So that becomes log base A of 16 plus log base A of 5. And I'm going to put a bracket around it now because it's more than one term. And then we're timesing this by, and then in the bracket, it's just going to be log base A of 16 minus log base A of 5, like that. Now, what can I do here? Well, firstly, I've seen these before. They are right there. It's P. So I can actually replace that, can't I? So I can just say that this just becomes P plus log base A of 5. And I don't need the times anymore. I can just do this. And then P minus log base A of 5. Like that. So now the question is, what is log base A of 5? Well, let's look at our points of reference. P or Q? Well, we're gonna look at Q quite clearly, isn't it? Because it's 25 there. Now, what I know is that, well, log base A, remember I need a 5. Well, I know that 25 or 5 is the square root of 25. So I'm gonna just say square root of 25 like that. And then what I can do is rewrite this as 25 to the half, just like we did before. And then I could bring that half to the front. So I get 1/2 log base A of 25. Now, again, we've seen this before. That is just what Q is. So therefore, it's just a half of Q, right? So therefore, let me just write this out. Log base A of 5, just so you can see it step by step. We said 5 is the same as the square root of 25, and then changed it to a half, brought the half down. We got the log base A of 25, which we know is Q. So therefore, log base A of 5 is half of Q. So that means I can put that there. So it actually just becomes P plus a half Q multiplied by P minus a half Q. Now, as I said before, there was a bit of symmetry here, and that is apparent because this is just the difference of two squares. So that is just going to be P squared minus square the half, a quarter, square the Q, Q squared. So the answer is P squared minus a quarter, Q squared. And that is it for question 9. Okay, so question 10 says, figure 4 shows a sketch of the circle C. The point P minus 1k plus 8 is the center of C. The point Q, 3k squared minus 2k, lies on C. K is a positive constant. The line L is the tangent to C at Q. Given that the gradient of L is minus 2, show that k squared minus 3k minus 10 is equal to 0 for 4 marks. So I've just got all of those pieces of information summarized here. Now we need to show that equation, right? Now remember what I always say with these types of questions. Draw a diagram. I mean, the diagram has been drawn for you, but visualize it. What I will do first is pretty much label everything they've told us, right? And maybe certain things can come to us. So firstly, the point P is minus 1 k plus 8. So let me write that there. So I'll do it like that. Minus 1 and then k plus 8. That is the point P. The point Q is 3k squared minus 2k. K is positive, right? You can always just put that there as well. K is greater than 0. The line L is the tangent to C, and the gradient of that line L is minus 2. So what I would do here is say, this line here has a gradient of minus 2. Now, we need to show this equation. We need to somehow create an equation, use algebra to get to this result here. Now, what do you do? Well, we're dealing with circles here, and what I always tell my students is, just think of one circle theorem when you see a tangent. The circle theorem that states that the tangent and the radius meet at right angles. So what I always encourage students to do is to just draw that radius if it hasn't been done already, right? So that line there, you know what I'll do actually? Let me get a line like that. But the thing is though, it doesn't actually matter to be fair. You know what I'll do? Let me rotate it. But then that rotates as well. Yeah, that's so long. Let me just get rid of it and then just draw a line because yeah, that's a bit long. So got that line there. Now, if that is gradient is minus 2, remember, these are perpendicular, aren't they? So if two lines are perpendicular, it means that the gradients are the negative reciprocals of one another, right? So if this line L has a gradient of minus 2, it means that the gradient of this line P to Q, which happens to be the radius, that has to be 1/2, isn't it? So we can use that result to form an equation because we've got 2 points. We've got P and Q, which both lie on the line PQ, the radius. We can use the change of y and change of y over change in x formula, equate it to 1/2, and that should give us our equation. So that is the type of things you want to be doing with these types of questions, okay? So what I'm going to do is I'll do it here. I'll do it on the next page. So part A, we've got the point P, which was minus 1. Was it k plus 8? Yes, it was k plus 8. And then the point Q was, what was it? 3k squared minus 2k. K squared minus 2k. Now, we know that the gradient of L is equal to minus 2. Gradient of PQ, right? Which is also the radius, right? Also the radius. This happens to be the negative reciprocal, isn't it? Because a tangent and a radius, they meet at right angles. So I could just say this is L, this is PQ, something like that, right? Okay. So what that means is that I can just use the change in y over change in x formula. So I'm going to say now grad of PQ, right? If I call this x1, y1, x2, y2, then I'm going to use the formula m is equal to y2 minus y1 over x2 minus x1, aren't I? So using that, it's going to be k squared minus 2k minus, and then k plus 8. I put it in a bracket, remember, because we're taking more than one term away, divided by 3 minus, and then another minus 1. And we know that this has to equal 1 over 2. So this is the equation that we are forming. Now remember, always have your show that at hand. So what I'm going to do, let me just screenshot that, just so we have it, right? Just so you have an idea of where it is you need to get to. So I'll put this here. I'll put this there. Okay. So this is where we are at now. This is just a matter of just doing some algebra, isn't it? So putting that there, that's going to be k squared minus 2k, and then minus k minus 8 when I expand that, and then over 3 minus minus 1 is a 4. That's a half, like that. And then that is going to be k squared minus 3k minus 8 over 4 is equal to 1/2. Cross multiply now. So it's going to be 2k squared minus 3k minus 8 is equal to 4 times 2 is 8, isn't it? No, just 4, sorry. The 2's already gone up, the 4 goes there, that's fine. And then it's going to be 2k squared minus 6k minus 16 is equal to 4. And then now I can move that 4 over to the left, can't I? So it becomes 2k squared minus 6k minus 20 is equal to 0. And now we're just going to divide by 2, isn't it? So we're going to have k squared minus 3k minus 10 is equal to 0. And that's exactly what they wanted there. And that is it. All right, as required. Perfect. And that's part A finished. Okay, so part B says, hence find an equation for C, and this is 4 marks. Now, I've just got the diagram, the piece of information, and the result that we proved in part A, just because of a couple of things. I don't want to keep going up and down. And as well as that, right, the first word of this question is hence. Use what you've done before, and we proved that k squared, or we showed, I should say, k squared minus 3k minus 10 is equal to 0, right? So we're going to need to use that. Now, they ask us to find the equation for C, right? C is a circle. So I need the equation of a circle. So the first thing that I would do is write down the general formula for the equation of a circle, which is if I have a center, AB, and a radius R, then the equation of a circle is x minus a squared plus y minus b squared is equal to r squared, right? So essentially, what we need to do is figure out the center of the circle and the radius. Now, the center was actually given to us, but it was given in terms of k, wasn't it? So the point P is the center. Let me write center here. Center P. This is minus 1 k plus 8. Now, the problem with this is that it's in terms of k. I need a natural numerical value. So when I look at this, my issue is that k. I need a value for k. And that is why we need to use part A, because we have an equation in terms of k now that we can solve. So what we're going to do to figure out what k must be so that we can figure out what the center is solve this quadratic. So it's going to be k squared minus 3k minus 10 is equal to 0. Factorize it, equals 0. K there. What two factors of minus 10 add to make minus 3? Minus 5 and a positive 2. So therefore, if I solve both of these equal to 0, k is going to equal 5 or k is going to equal negative 2. So we've got two options. Now, there's only one circle, so there's one center. So that means that there's one value of k. So which one do we pick? Have a look at your pieces of information. They told us in the third bullet point that k is a positive constant, i.e. k is greater than 0. So because of that, we can deduce with absolute certainty that k must be 5 and not minus 2. So what I'm going to say here is since k is greater than 0, it implies that k is equal to 5, right? So we can say that that is fine. So what I'll do, I'll put a cross here, right? I'll put a circle here, put a cross there. I'll cross that one out. I was choosing k equals 5 because k is positive. Now, with that being said, that would allow us to calculate what the center is, right? So the center is going to be minus 1. Let me write k is equal to 5 here. If k is equal to 5, 5 plus 8 is 13, right? So the center of our circle is minus 113, which would mean then that we can now update this, right? Let me put this is equation 1, right? Equation 2 has now been updated. So it's going to be x, because that's a minus, we know that it has to be a plus, isn't it? So x plus 1 all squared plus y minus 13 all squared is going to equal r squared. So now we are on our way, on our journey to figure out what the equation of the circle is. We now have to figure out what the radius is. Now we can do that because remember what we saw in part A, P to Q is the radius. We have the coordinates of P, we have the coordinates of Q. We could use the distance formula to calculate what the radius must be, isn't it? So let's do that. So P we know is minus 113, right? Q, what was Q? Q was 3 something. K squared minus 2k. So 3, and then we know that k is equal to 5. So it's going to be 5 squared minus 2 lots of 5, isn't it? Which is 3, and then, whoops, I put the bracket after the 3. That is so funny. And then 25 take away 10 is 15. Yeah? So therefore, we've got P as minus 113. We've got Q as 315, right? The radius, whoops, let me write again, write a bit neater. The radius is going to equal the magnitude of PQ, isn't it? Right? And that is just going to be the distance formula. We're going to do x1 minus x2 plus y1 minus y2. So it doesn't really matter which one I use. It's going to be, you know what I'll do? I'll use 3 minus minus 1. So I'll do this one minus that one, and then that one minus that one. So it's going to be 3 minus and then a minus 1 all squared plus and then 15 minus 13 all squared, which is equal to 3 minus minus 1 is a 4. 4 squared is 16. Now that. And then plus, and then that is going to be 15 take away 13 is 2. 2 squared is 4. So it's the square root of 20, which is equal to 2 root 5, because that's root 4 root 5, isn't it? That's square root of 20. Yeah, so it's not there. So therefore, the radius is just 2 root 5. And in the formula, you use r squared, isn't it? The square of that is just 20. So therefore, r squared is 20. So therefore, the equation of the circle, right? Equation for C is just going to be x minus, what was it, 1? X plus 1, sorry. X plus 1 all squared. X plus 1. You know, let me just write. I'm getting used to this new whiteboard. Makes the writing a bit different. X plus 1 all squared. Was it plus? Yep. Y minus 13 all squared. And this is going to equal r squared, which is 20. And that is your final answer. And that is question 10 finished. Okay, so question 11 says the prices of two precious metals are being monitored. The price per gram of metal A, VA pounds, is modeled by the equation VA is equal to 100 plus 20e to the 0.04t, where t is the number of months after monitoring began. The price per gram of metal B, VB pounds, was modeled by the equation VB is equal to PE to the negative 0.02t, where P is a positive constant and T is the number of months after monitoring began. Given that VB is equal to 2VA when T is equal to 0, find the value of P for part A, and this is 2 marks. So, find P. They've given us this equation here. So, what I would do is just literally put that in, to be fair. So, I would just say, well, VB is P, e to the negative 0.02t. And this is going to equal VA, which is, or 2VA, I should say, which is going to be 2, and then multiplied by 100 plus 20 e to the 0.04t. So this is the equation VB is equal to 2VA. This happens when t is equal to 0. So what we're going to do now is make t 0. So doing that will give us PE. That whole power would become 0 with it. So that's going to be 0 there. It's going to be 2 times 100 plus 20. And then again, the power would become 0. Now, e to the 0 we know is 1. So it's P times 1, which is just P. It's going to be 2 times 100 plus, that's going to be 20, isn't it? So therefore, P is just equal to 2 times 120, which is 240. So therefore, right here, P is equal to 240. That's part A. Part B, it says when T is equal to capital T, the rate of increase in the price per gram of metal A was equal to the rate of decrease in the price per gram of metal B. Find the value of capital T, giving your answer to one decimal place for 4 marks. Now, you can't use your graphical calculator for this one. So, what do we want to do? First thing, when you see this word rate here in an exam, right, rate there, rate of increase, rate of decrease, that is just another way of saying we need to differentiate. So whenever you see that word rate, remember the rate of change of a function is when you differentiate it. So you just need to differentiate this. Now, rate of decrease and rate of increase and rate of decrease of both of these metals. So VA, we know was equal to 100 plus 20 E to the 0.04t, right? Now VB is equal to P, which is 240, e to the negative 0.02t. Now, just one thing to make a note of, right? They're asking us to find capital T when the rate of increase is equal to the rate of decrease. Now, the rate of increase is just going to be when we differentiate this, right? Whatever that would be. This is going to be positive, right? Now, this one, because this is a minus here, the rate of decrease, right, or the rate of change of VB is going to be negative. However, we just want to compare the numerical value, right? Essentially the magnitude. We want to just compare the two rates, the numerical value. So what we're going to do is once we differentiate this one and it's negative, we're going to essentially ignore it just for the fact that we're looking for the actual values and we don't care about the signs. So let's differentiate these. Differentiate this one. The 100 would disappear. Now we're differentiating an exponential. How do we differentiate those? Let me just do this very, very quickly. I'll just give you a quick rule. If y is equal to e to the kx, right, then dy dx is just equal to ke to the kx. You always just bring that number, that constant at the front. It's essentially differentiating it, the power, and bring it to the front, which is the chain which you guys will learn when you get to year 13. So yeah, this one, the 100 will disappear. This would become 20 times by 0.04 e to the 0.04t, right? And then that there, 20 times 4 is 80. So that's going to be 0.8, isn't it? That's going to be 0.8 e to the 0.04t. This one is going to be the VB dt. This is going to equal 240 times by negative 0.02 e to the negative 0.02t. And then what's that? 2 times 240 is 480. So it's going to be 480. It's going to be 4.8. So negative 4.8 e to the negative 0.02t. So these are our rates of changes respectively, right? Now remember, we're comparing the rate of increase to the rate of decrease. So we do not care about this numerical, this sign, I should say, right? We just want this part, right? This is what we want. So when we're solving this, we're going to equate 0.8 e to the 0.04t with the thing in blue without the minus, okay? So I'll do it on this side here. So 0.8 e to the 0.04t is going to equal 4.8 e to the negative 0.02t. And to be fair, they did say that this happens when t is capital T. So instead of writing lowercase t, I'm going to write capital T. Although they won't penalize you for that, to be fair. Okay, so now doing this, how do we solve this? I'm going to divide this on the left, divide that on the right. So it becomes e to the 0.04 capital T over e to the negative 0.02 capital T. And this is going to equal 4.8 over 0.8. Right hand side, that's the same as 48 divided by 8 if I times top and bottom by 10, which is 6. So that's 6 on the right. This side here, we're dividing, we take away the powers, but remember, we're going to have a double negative, isn't it? Because it's going to be 0.04 minus 0.02, which is going to be 0.06. That. And then now, how do we solve this? How do we find t? Well, this is an exponential equation because the thing that we're trying to find is in the power, so we need to use logs. This is a base of e. We're going to take the natural log of both sides. So I'm going to take the ln of both sides. So it's going to be the ln and then that essentially. And then what will happen is that and that cancel. So it becomes 0.06t is equal to the ln of 6. And so therefore capital T is equal to ln 6 over 0.06, whatever this number is here. So I'll put this into the calculator and see what we get. ln 6 over 0.06. That is equal to 29.86. Blah, blah, blah. And then what did they want it to? What did they say? To one decimal place. So that's just going to be 29.9, isn't it? 29.9. So the answer is T is equal to 29.9. What is this in? Months? Yeah, perfect. It's in months, so 29.9 months. And that's it. Finished. Okay, so question 12 says, Figure 5 shows the plan view of the design for a swimming pool. The pool is modeled as a quarter of a circle joined to two equal-sized rectangles as shown. Given that the quarter circle has radius x meters, the rectangles each have length x meters and width y meters. The total surface area of the swimming pool is 100 meters squared. Show that, according to the model, the perimeter p meters of the swimming pool is given by p is equal to 2x plus 200 over x, and this is a 5 marker. Now, this question here, modeling with differentiation, comes up all the time, and it's the same process. You essentially need to, based on information given to you, form at least two equations. One of the equations you're going to use algebra to rearrange and put into one of the equations to get the result that they want. So let's go ahead and make a start. So what I've done is I've just summarized everything we need here. So let's have a look at what we've got here. So immediately we need to show what the perimeter is. So the first thing that I would do is find an expression for the perimeter. But let's first label our diagram. Okay, so what do we have? We've got the rectangle x of y. So this is going to be a y over here. That is also a y. That is an x. That is a y. Now, the last part of the perimeter is going to be this here, isn't it? Now, remember, they told us that this is a quarter circle with a radius of x. So with that being said, the circumference is going to be 2 pi r divided by 4. So what I'm going to do is I'm just going to put an expression for the circumference here. So, or a quarter of the circumference. So it's going to be 2 pi. The radius is x. So I can put an x there, sorry. And I'm going to divide this by 4. This will be an expression for the quarter, for a quarter of the entire circumference. So that is fine. And obviously I can just simplify it to be pi x over 2, but I'll do that. I'll do that here. I'll do that here. So it's super clear. 2 pi x over 4 is the same as that goes into 2 once, that goes into 2 twice. It's pi x over 2. Perfect. So now I'm in a position to find the perimeter. So I'm going to say P is equal to, and then I'm going to add all of these, aren't I? So I'm going to add, I'll do circle this one, that one, that one, that one, that one, that one, and that one. All of these sides together will make the perimeter when I add them. So that one, 2 pi x over 4, which we know is pi x over 2. Simplify, it's going to be pi x over 2 plus how many y's? So, I'll just do it in order. Y plus x plus y, y plus x plus y, y plus x plus y, plus a y plus x plus a y, plus a y plus an x plus a y. Okay, now let's simplify this a bit more. So P is going to equal pi x over 2 plus how many x's do we have? I'll do the x's first. X plus, we've got 2 x's, and then we've got 4 y's. Okay, so this is the answer, isn't it? This is the perimeter. Now remember, it's a show that question, right? We know that this is definitely an expression for the perimeter. However, when we compare it to what they want, we do not have that expression. What is the problem? We've got y's. And this is where that second equation comes in, which I was telling you about, right? We need to form another equation, get it in terms of y, plug it back into this equation for p. So how do we do that? Always have a look at the information given. They told us that the total surface area of the swimming pool is 100 meters squared. So that way we can find the expression for the surface area, equate it to 100, and then use algebra to get it in terms of y. So let's go ahead and do that. So let's see. So these two are very, very easy. The area of this rectangle is going to be xy. This is the same. That's going to be xy. That's fine. And then the area of this quarter circle, well, the area of a circle is pi r squared over pi r squared. It's a quarter, so it's going to be pi r squared over 4. So it's going to be pi. The radius is x, so it's going to be pi x squared. And then we're going to divide this by 4, isn't it? And now these are going to be the area of each of the surfaces. That one, plus that one, plus that one. So therefore, we could say then, from there, that the surface area is going to equal pi x squared over 4 plus xy plus xy, 2xy, isn't it? And we know that this is equal to 100. So now we are here. Remember, we're trying to show that P is equal to that expression there, 2x plus 200 over x. So we need to eliminate that variable y, don't we? We can do that by rearranging this equation. So let's go ahead and do that. So should I times by 4 first? You know what I'm going to do? I'm going to take that over. So I get 2xy is going to equal 100 minus pi x squared over 4. Like that. And then what I'm going to do is, just so I can get it in a really nice form, I'm going to combine the fraction. So I'm going to have 2xy is equal to 100 is the same as 400 divided by 4. I want the same denominator, like that, over 4. And then 2xy is going to equal 400 minus pi x squared over 4. And then now I can divide by the 2x. Now remember, when you divide by this 2x here, you just times it with the 4 in the denominator. So it's going to become 400 minus pi x squared divided by 4 times that 2x, which is going to be 8x, like that. Let me write divided by 2x on both sides. Yeah, okay. So this is an expression for y, isn't it? Now, before I plug it in, I'm going to do a bit of simplification because I can see x's cancels and so does the 4 and the 8s and so on and so forth. So let me separate this. So it becomes 400 over 8x minus pi x squared over 8x. And then simplifying that, 400 divided by 8, 4 goes into 4 once, 4 goes into 8 twice. So it becomes 100 over 2x, 100 over 2x. And then this one, and I can drop an x there, cross that out. That's just going to be pi x over 8, isn't it? And then we could put a minus in there. So that is an expression for y, this thing right here. And now I'm going to substitute this into the expression for the perimeter. So what I'll do, yeah, let me just grab this. I'll put this underneath. Okay, perfect. Copy, please. And I'll put this here. And then we can basically get started. So we can basically finish this off. So paste, whoops. Okay, so I've got that there. Okay, and then I think I'm missing a bit of it. 2x plus 4y. Okay, and then that expression, that, and then that is y, isn't it? So I've got y is equal to 100 over 2x minus pi x over 8. And then now I'm going to plug this in into there. So therefore it's going to become P is equal to pi x over 2 plus 2x plus 4 lots of y, which is 100 over 2x minus pi x over 8. And then now let's expand that. Let's expand this. So that's going to be 400 over 2x minus, and then that's going to be 4 pi x over 8. And then we still got the pi x over 2 plus 2x. And then equaling that now, do a bit of tidying up. Pi x over 2 plus 2x. 400 divided by 2 is 200, so it's going to be 200 over x, isn't it? And then this one, 4 divided by 8 is a half, so that becomes minus pi x over 2. So this is the perimeter. Now, when I look at this, pi x over 2 minus pi x over 2, goodbye, goodbye. That means we have P is equal to 2x plus 200 over x as required. And that's it. That will give you the 5 marks. So again, it's the same thing each time. You get 2 equations, you use algebra to rearrange one, plug it into the other, and it's just about simplification. That's it. Finished. Okay, so part B says, use calculus to find the value of x for which P has a stationary value for 4 marks. Now, whenever you see that word stationary, this is just calculus, right? We need to differentiate. And it means specifically that dy dx is 0. So I'm going to do here, I'm just going to put dy over dx equals 0 there. That's what it means. So all we need to do is remember we're looking for the value of x for which P has a stationary value. So we need to differentiate this. However, before I do that though, I want to put it into a form which I can differentiate. So the 2x will stay the same. 200 over x, that division of x you can bring up to become x to the negative 1. So now we're in a position, let's differentiate dp over dx. That will equal 2 plus, and then the minus 1 will drop to the front, so minus 200. and then x to the negative 2. So essentially it's just 2 minus 200 x to the negative 2, isn't it? So I can move that there. And then because we want a stationary value, we need to equate it to 0. So how do we solve this? Again, very, very simple. Whenever you see a fractional power, so not a fractional power, a negative power like that, rewrite it as a fraction and you'll see it's quite easy to solve. So I'm going to write this as 2 minus 200 divided by, that's going to be x squared, isn't it? And then this equals 0. And then I'm going to move that over. So 2 is equal to 200 over x squared. And then now we can just times up that denominator, can't we? So it's going to be 2x squared is equal to 200. So therefore, x squared is equal to divided to 100. So x is going to be the square root of that, which is going to be plus or minus 10. However, x is the radius, isn't it? Which cannot be negative. So therefore, we can say that x is equal to 0 since x must be greater than 0. And it's because it's the radius, right? So that is it, because it asks us for the value of x, isn't it? Yes, we found the value of x. X is 10. Now, part C, it says prove by further calculus that this value of x gives a minimum value for p. Now, again, these questions are the same, right? Now, for part C, we're looking at the second derivative. It says use further calculus, right? Now, dy dx is your stationary value. You make it equal to 0. Now, at that point when it's equal to 0, you're not sure what type of stationary point you have. Is it a maximum? Is it a minimum? Is it a point of inflection? We don't know. The second derivative helps us understand which type of stationary value you have. So what you're going to do now is, let me write dp dx again. dp dx, that was 2 minus 200 to the x minus 2. I'm going to differentiate this again. So d squared p over dx squared. That gives us, the 2 will disappear. The minus 2 drops to the front with the negative 200. It's going to be positive 400 x to the negative 3. Now, all we need to do here is simply plug in our stationary value. And now, let me just write this little, have I got room? No, it's the next question. I'll just do it here, right? So this is your rule. So let me put a box here like this, like that. So if your second derivative, I'll do it in terms of y and x, right? If this is greater than 0, then you've got a minimum point. If you plug in your stationary value into your second derivative and it's less than 0, then you've got a maximum point. That's just something you just need to remember. So all we need to do is plug in x equals 10 into the second derivative, see what we get, and then it will justify the question. So let's do it here, just so there's room. So I'm going to plug that in. So d squared p dx squared at x is equal to 10. That will give us 400, and then 10 to the negative 3. Yeah, that's fine, isn't it? And what's that? That's 400 over 1,000. No? 400 over 1,000 by 4 over 10 is 0.4. This number is greater than 0. So therefore, we have a minimum, don't we? And let's just use the concept of the question. Prove by further calculus the value of x gives a minimum value for p. So therefore, x is minimum value. So you could just say, therefore, x is, or x equals 10, I should say, is a minimum value for p. And that is it. That is a part, I think this was part C finished. Perfect. Okay, so part D says access to the pool is by side AB shown in figure 5. Given that AB must be at least 1 meter, determine according to the model whether the swimming pool with the minimum perimeter would be suitable. Okay, now firstly, side AB is this one over here, which we can see quite clearly is Y. Now, for me, what that tells me is that I want to get the equation or the expression for Y, which we found. And the expression for Y was this one, right? And I realized that 100 over 2 is 5, isn't it? So 50. So we could say it's 50 over x minus pi x over 8. So let me write that there. So y is equal to 50 over x minus pi x divided by 8. Now let's read the question again. A term equal to the model whether the swimming pool with the minimum perimeter would be suitable. Well, when the perimeter was at its minimum, we showed that that was when x was equal to 10. So all we would need to do is plug in x equals 10 into our expression for y and see whether or not it's more than 1 meter. If it's more than 1 meter, then it's suitable. If it's less than, then it's not, right? So let's plug it in and see what we get. So we're going to have y is equal to 50 over 10 minus pi lots of 10 divided by 8. And then let's see what we get. So plugging this in, it's going to be 50 over 10, which I know is 5, but I'll just write like that anyway. Minus pi 8 there, and then the 10 there, like that. And this is equal to 1.073, right? And that is more than 1. So since it's more than 1, we could say, let me try here. We could say, therefore, minimum perimeter is suitable. And that's it. Finished. Okay, so question 13, part A says, show that the equation sine theta multiplied by 7 sine theta minus 4 cos theta equals 4 can be written as 3 tan squared minus 4 tan theta minus 4 is equal to 0 for 4 marks. Okay, so again, a typical show that question. They give you some equation and you've got to use your trigonometric identities to write it in a different form. So let's go ahead and make a start. I've got it summarized underneath here. So the first thing that I would do is expand. I'll just expand that. So if I do that, that will give me 7 sine squared theta minus 4, and I'll put the sine theta first. 4 sine theta cos theta is equal to 4. Now, we need tans, don't we? So for me, what I would do is, well, we know our identities, and this is a main thing as well, by the way, when you're doing these types of questions. You're in year 12, you're only taught 2 identities, essentially. So you've got sine squared plus cos squared is equal to 1, and you've got sine over cosine is tan, right? And then obviously you got the other two by rearranging this. 1 minus sine squared and 1 minus cos squared. So what do we do? This is where we're at. Now, for me, because I need a tan squared, right? I would try and create that by looking at this identity, right? Sine over cos is tan. But if I put a square there, then I'll put a square there and a square there as well, wouldn't it? So for me to get a tan squared, what I could do is introduce a denominator of cos squared. And the only way I can do that is by dividing through by cos squared. So I'm going to do that there. So if I do that, I would have 7 sine squared theta over cos squared theta, like that. And then that would be minus 4 sine theta cos theta over cos squared theta. And then this is going to equal 4 over cos squared theta. 4 over cos squared theta. Okay, let me just write this a bit neater. It's a bit messy there. There you go. Okay. And then let's simplify. So this one, sine over cosine, that is tan squared. So that's going to be 7 tan squared. And then what do we have here? Well, I've got a cos that can cancel there. One of them can cancel there. So that means I'm going to have 4 sine over cosine, which is 4 tan. So I am here, and then this is 4 over cos squared. Now, when I'm looking at this, well, for me, when I look at this, I think you can use and identities that you're not introduced to yet in year 12, so I won't do it that way. But let's say you've only learned these two, sine over cos is tan and sine squared plus cos squared is 1. It's not the end of the world. Now, remember what I always say, whenever you're doing show that's, always have the thing that you're trying to show at hand to guide you, right? So for me, immediately, right, because I've got a 7 tan squared theta, and I know I need a 3 tan squared theta, I would introduce it. You can kind of think of it as just thinking outside the box, making things happen. So what I'm going to do is I'm actually going to rewrite this as 3 tan squared theta plus 4 tan squared theta, right? I can do that for sure. I've just splitting this 7 into 3 and 4. Minus 4 tan is equal to 4 over cos squared. Now, how does that help us? Well, remember, if I look at this, I've got the 3 tan squared theta. I've got the minus 4 tan theta in the show that. The only problem are these two. Now, potentially, can we combine them? Can something happen with these two, right? The reason why I'm going to look at those is because I know that I've got these two done. This is done. This is done, right? It's right there. That and that. They are done. So let's have a look at those two, the terms that I haven't highlighted, and see if there's anything we can do. Now, Immediately, remember identities. Tan squared, again, we can replace it. We can rewrite it as sine squared over cos squared. And the reason why I will do that is because I've got a denominator of cos squared theta here. If I rewrite it in terms of sine over cosine, I can reintroduce that denominator and then combine them. So let's do that. That is going to be 4 sine squared theta over cos squared theta, isn't it? Like that. And then what I'm going to do actually, I'm going to put equals 0 here. I'm going to move this to the left. I'll put that there. Minus 4 over cos squared theta. And then the two I've highlighted in blue, I'm going to put here. So 3 times squared theta. And then minus 4 times theta. Yeah. Okay. So those two are done. This here, I'll put in here. There's a tick. That's done. We need to see what that becomes. Now, again, we can use our fractions. We can combine these. So let me put this here. Or, I'll just carry on from there. Same denominator. We can combine it. So it becomes 4 sine squared minus 4 all over cos squared theta. Now, just looking at that in itself, well, firstly, I've got a common factor of 4 on the numerator. When I see anything like that, just take it out, see what happens. 4 sine squared theta minus 1, and then over cos squared. Now, this looks familiar to me, right? Sine squared minus 1, 1 minus sine squared. Remember your identity, sine squared plus cos squared is equal to 1. So how can I get sine squared minus 1? Just move that over. So I'm going to say then, oh no, other way, sorry. I'm going to move, no, that's correct. I'm going to move that there and I'm going to move that there, isn't it? To get the sine squared minus 1. So sine squared theta minus 1 is going to equal negative cos squared theta. And that means I can put that there. So it becomes 4 and then minus cos squared theta divided by cos squared theta. And that's great because the cos squareds cancel 4 times a minus 1. That is just negative 4. So therefore, this whole expression here, these two, that right there is just negative 4. So therefore, we've got the result. So let's write it out to finish off. So therefore, with all of that, we're going to have 3 times squared theta minus, let me just see again, minus 4 times theta, which we already had. And then minus 4, because this thing here, we worked out, this thing here, this thing right here, this is just minus 4. So therefore, we can put minus 4 there and then equals 0 as required. So as required. And that is it for part A. So this is a very funny type of question. I haven't really seen much like these, but again, it's good that they put these in here because it really requires you to stretch your mind and think outside the box. So yeah, that's it. That's part A finished. Okay, so part B says, hence solve for x between 0 and 360, sine x times 7 sine x minus 4 cos x equal to 4, giving answer to one decimal place for 4 marks. Now, this question, very, very typical. Part A is always a show that one equation is equal to the other using identities, and then part B says hence solve. So the reason why I've got part A underneath is because of the fact that we're going to use it. Instead of using this equation right here, which is the same thing as this one, but they've replaced theta with an x, we're going to use what we know it can be written as, which is this one. Now, this one is a disguised quadratic, isn't it? So we could use that to solve it. So that's the whole point of this type of question, this topic. You have certain trigonometric equation which you don't like the look of. You use identities to write it in a form that you can easily solve. So we're going to rewrite this in terms of that, right? But obviously we're going to use x's instead because that's what we're dealing with in part B. So I'll do it here. So we're going to solve them for part B. We're going to solve 3 tan squared x, and it was minus 4, isn't it? Yeah, minus 4 tan x minus 4, yeah, is equal to 0. And we're solving this between 0 and 360. So firstly, as I said before, this is a disguised quadratic, isn't it? So we can factorize. So what I'm going to do is factorize this. So this is a coefficient of a square term, which is more than 1. So we're going to use the AC method. We're going to do 3 times minus 4. That is equal to minus 12. I need 2 factors of minus 12, which will also add to make this negative 4 here, which is going to be a negative 6 and a positive 2, right? So to factorize this, very quick method, you're going to do bracket like this, bracket like this, bracket like that equals 0. You're going to drop the power. It's going to be 3 tan x there. It's going to be a 3 tan x there. And then you just literally put these in. So minus 6 goes there. plus 2 goes there. And then once you're here, you look at each bracket. Do any of these factorize further? This one does. I can pull out a 3. If I pull out a 3, it's going to be tan x minus 2. Can't pull out anything from there, so I'll leave it like that. Plus 2 is equal to 0. And then I just literally cross that out. And this is the factorization. So this is a very quick trick. Some of you may use it. Others may split it in terms of minus 6 tan x, like that, plus 2 tan x, like that. Let me just do it here. Minus 4 and then 3 tan squared x, like that. And then you take out the 3 tan x there, take out the 2, and then you get the same thing. Just depends on what you prefer. Yeah? So doing this one now, we can see quite clearly we set each of these equal to 0. Tan x minus 2 equals 0. Or this one, 3 tan x plus 2 is equal to 0. We've got to solve both of these now. So tan x equals 2. And then 3 tan x equals negative 2. That means that tan x is equal to negative 2 over 3. So these are our two equations that we need to solve. So let's solve these very, very quickly. Tan is always the easiest one. Tan repeats every 180 degrees. So let's first do the tan inverse of our calculation. So tan inverse of 2, I'll do that here. Tan inverse of 2, this is equal to 63.43, blah, blah, blah. So because it says one decimal place, I know that I can round it to one decimal place now. So that means that x is going to equal 63.4 degrees. And then the next value, we just add on 180, isn't it? Which is going to be 243.4 degrees, isn't it? Because if I add on 200, 263, yeah, perfect. And if I add a 180 to that again, that will take us outside the range. Remember, it's between 0 and 360. So these are the answers for that equation. And then now we're going to do this one. So we're going to get it again. We're going to change that to a minus 2 over 3, aren't we? So minus 2 divided by 3. This is equal to minus 33.69. So I'm going to do it here. X is going to equal, let me just double check. I've written it correctly. Yeah, that's fine. Minus 33.7. Now, what we're gonna do is we're gonna add on 180. Remember, it needs to be between 0 and 360. So I'm gonna add on 180 onto that one. That will give me 146.3, isn't it? To one decimal place. So 146.3. And then if I add it again, 180, I get 326.3. And that is our answers, not this one, but these two, because that's between 0 and 360. So what I would do just to finish off, I'll say x is going to equal, I'll do it in order of size. Yes. So 63.4 degrees. That's the first one. The next one is 146.3. Next one is 243.4. And the last one is 326.3 degrees. And that is part B finished. All of the 4 solutions. Done. Okay, so part C says, hence find the smallest solution of the equation sine 4 alpha times 7 sine 4 alpha minus 4 cos 4 alpha is equal to 4 in the range 720 to 1080. Give your answer to one decimal place. Okay, so this one here, as you can notice very clearly, right? It's the exact same equation. The only difference is x has now been replaced with 4 alpha. So what I'm going to do is I'm going to say x is equal to 4 alpha. Now, what do we know about x when we solved it? There were 4 solutions between 0 and 360, right? So what I'm going to do, I'm just going to grab these, right? And I'm just going to copy it and I'm going to replace it. I'm going to replace the x with 4 alpha. So do that there. Place that over right here. Perfect. Okay. So what I'm going to do is I'm literally just going to replace that with a 4 alpha because that's what we're dealing with, right? Now, we want the small solution between 0 and 720 and 1080. Where are we? So we're here. So immediately, because of the fact that I need alpha, I'm going to divide this by 4, aren't I? So that means that alpha is going to equal each of these divided by 4. Now, let me just get my calculator and just do the first one. 63.4 divided by 4. This is equal to 50.85. Now we know that this value here is the start of a cycle. This is the first solution in the start of a cycle. This repeats x and for alpha the same. This repeats every 360 degrees, doesn't it? Right? Now, alpha then, by definition, if we're dividing by 4, it's going to repeat every 90. Let me write that there. Alpha repeats every 90. So the range is between 720 and 1080. That's fine because 90 goes into 720. So to get the answer, remember 720 is going to be the beginning of a cycle. To get the smallest solution, we're just going to add on this value here, the first answer in the cycle, onto the beginning of the cycle that we're dealing with, which is 720. So therefore, the answer is going to be 720 plus this first solution, 15.85, and that will equal 735.85. And then they want it to one decimal place, which is going to be 735.9 degrees. And that is our answer for part C. Okay, so question 14, it says prove using algebra that n squared plus 5n is even for all n in n for 4 marks. Okay, so prove. Very, very straightforward question. You've got an expression n squared plus 5n. You need to show it's even, and n is defined as the natural numbers. So what are the natural numbers? They are just positive integers, aren't they? So what we want to do is write expressions for these positive integers, and there are only two, even or odd numbers. So we're going to say n, for the first case, is going to be n equals 2k, which is going to be an even number, like that. And in the second case, I put number 1 here, and I put number 2 here, is going to be one more than that, which is going to be 2k plus 1, and this is going to represent our odd numbers. And I'm just going to say k is an element of the natural numbers too, just so we know that everything's an integer. Okay, so all we need to do now is substitute both cases into our expression here and show that when we substitute it, we get an even result out. If both of them are even, then that would mean that n squared plus 5n is even for all n and n. So let's make a start with case number 1. So case number 1, n equals 2k. If I plug that into that expression, it's going to be 2k all squared plus, sorry, 2k all squared plus 5 lots of 2k. And now let's expand that. What do we get? We're going to have 4k squared. 5 times 2 is 10. This is 10k. Now, how do we show that this is even? Now, remember, an even number is an integer multiplied by 2. 2 times an integer. Let me write this here, just so it's clear. An even number is equal to 2 times an integer, isn't it? So if we could show that our expressions are 2 times an integer, then it must be even, which we can do here, because if I take out a 2, I'll get 2k squared plus 5k. Now remember, k is a natural number, so whatever this is, right, has to be an integer. We plug in a value of k, which is an integer, into that expression that is an integer. So therefore, this is just 2 times an integer, and that is an even number, right? So therefore, case number 1, when n equals 2k, we get an even result out. Let's do case number 2, n equals 2k plus 1. So let's plug that in. That's going to be 2k plus 1 all squared plus 5 lots of 2k plus 1, isn't it? So doing that, expanding that, that is going to be 4k squared plus 2k times by 1 is 2k, double that, 4k plus 1. And then plus, that's going to be 10k. That's going to be 5. Now, what do we get here? So 4k squared. We've got a 4k plus a 10k, which is 14k. And then we've got 1 plus 5, which is 6. Now, is this even? Absolutely. Let's take out a 2. We can. It'll be 2k squared plus 7k. And then it's going to be plus 3. Now, as I said before, remember, k is an integer, right? A natural number. If I plug anything into there, that bracket will be an integer. Doesn't matter what k is. So therefore, we can say for absolute certainty that this is the same as 2 times an integer, which is an even number. So therefore, case number 2 has been proven. So now we've proven both cases, you need to tie it all together. What you're going to say now is that therefore, let's say that when n equals 2k even, we get an even result. Or we could say n squared plus 5n is even. Yeah. And then when n is equal to 2k plus 1, odds, n squared plus 5n is still even. Right? And then now once you've shown that you've justified that, to get the final mark, just literally write what they asked you to prove. It said prove using algebra that n squared plus 5n is even for all n and n. So therefore you're going to say for your answer, n squared plus 5n is even for all n and n. And that is it. That is the question finished. There is another way which I'm going to do as well, which I think is pretty cool. And then you guys can let me know which way you prefer. So let's get into it. Okay, so the second way, which I think is pretty cool, right? Probably what I would do is, well, you've got n squared plus 5n. What I would do is actually look at this. Can I do anything with this? For sure, you can factorize it. If I take out an n, I'll have n plus 5. Now, we know that n is a natural number, right? So, for example, let's say n is even, right? An even number. Then what will happen is that you're going to have an even number n, right? And then you're going to times by that same even number plus 5. Now, looking at that, well, I've got an even number. Well, what's an even number plus 5? Well, what's an even plus an odd number? It must be odd. So therefore, we have an even times an odd number, which has to be an even number, isn't it? So that's case number 1, right? And then obviously case number 2, n is odd. Same thing, plug it in. N plus 5. Odds, odd plus 5, right? Let me just remove that bracket, make it a bit neater. Okay, and then now this is odd. And then, well, what is an odd number plus 5? Another odd number. They must make an even number. So you're going to have odd times by even, which again is even. And now you've proved both cases. And now once you're here, case 1, case 2 have proved, even, odd, you can just use the statement, right? So you can say, therefore, n squared plus 5n is even for all n in n. And I think that would be okay, you know. I don't think we need to. I need to check the mark scheme again, but I think that'll be okay. We've proved both cases. N is a natural number, so it's either even or odd. We've shown that both examples give evens, and then you use the statement. I think that would be it, and that's very, very quick. But yeah, let me know how you guys did it in the comments. And yeah, that's question 14 and this paper finished. Hey guys, hope you guys are doing well. So yeah, that's the paper in its entirety, 14 questions done. I hope you guys found it helpful. Any questions that you may have found a bit tricky, I'm hoping that this walkthrough has helped you with your revision. So yeah, couple of more papers to go. I'm sure the stats and mechanics papers will be out shortly after this one, if it isn't out by the time you're watching this. And obviously I'm going to do the A-level ones as well. So yeah, as always, if you found it helpful, please like, comment and subscribe. That really, really helps. If you find that, if you know anyone that would be interested in watching these videos that would find them beneficial, then feel free to share it with them. Also, we'll be doing group classes throughout the entire academic year, which I'll put more information on in the description for anybody that wants some extra support. But yeah, that's pretty much it. Have a good evening, morning, whatever the time is that you're watching it. And yeah, I'm sure I'll see you guys soon in another video. Take care. Bye bye.